Welcome to the video. This is soundproofing for beginners, or soundproofing for dummies, as the thumbnail says. Now, the goal of this video is to take you from feeling stressed and annoyed with the noise to knowing exactly what it takes to soundproof your home. Now, if you follow this program, it will get you to a stage where you don't need your neighbours anymore. Now, I know that's a bold claim, but this is something I've been meaning to put out there for years and years now, because there's so much misinformation out there. There is so many soundproofing suppliers trying to take your money and not provide any value in return. And I've had enough of all of that. And I thought, I'm just going to give everything away for free to the DIY community once and for all. I'm going to invite you in to my soundproofing den as I walk you through every component that you're going to need directionally correct, so you can get that noise reduction as quickly as possible, without all the fluff, without all the showmanship, without having to renovate your room 3 times like I did to my own home. By the end of this program, you're going to be the most confident, competent soundproofing DIY you could possibly have dreamed of being. So if that sounds good to you, I encourage you to bookmark this video, add it to your favourites, subscribe to the channel if you want to, because over the next few sections of this course tutorial, we're going to be covering what your expectations should be in terms of noise reduction for the amount of renovation that you decide to do. Expectations including time, costs, the amount of work involved, and the amount of noise reduction. We're going to look at common myths and mistakes, and I'm going to share with you my award-winning 4-step soundproofing method. We're going to go through an actual soundproofing installation, and I'm going to share with you step-by-step installation of one of my systems. I'm also going to be helping you develop an action plan specific to your house. We're going to be looking at materials, how much they cost, and where to get them from. I'm going to help you get the most value out of those soundproofing materials that you decide to invest in. By the end of this course tutorial, there's not going to be much you need other than to start ordering materials and putting them on the wall. So why am I doing this? Well, some of you may know me and some of you not know me. Some of you might be subscribed to my channel already. And over the years, I've managed to build a phenomenal soundproofing community. And the reason for that is through transparency and vulnerability of sharing my soundproofing techniques and sharing real life case studies of actual soundproofing installations in real life homes, and sharing the strategies and insights and lessons that I've learned from soundproofing thousands of homes in the UK. My money isn't made from selling soundproofing materials. I'm not a soundproofing material supplier, and my installation teams can only help out a small number of people each year. You see, I have a much bigger cause to empower people and help people with noise in their home, because I believe that everybody should be able to enjoy peace and quiet in their home. I believe that the noise is caused by the construction of the building, and I believe we need to build better quality homes. You see, it's easy to take the edge off the noise from the neighbours, to change the way that the sound feels in your home, to put a barrier on that separating wall between you and your neighbours in every room in your home that has a separating party wall is what every YouTube video is trying to sell you. But the truth is, it only takes a slight bit of noise to come through for you to feel stressed and annoyed with the noise, and it affect your quality of life. Now, what a lot of people don't realise is it takes a lot of work to get a significant reduction in noise. A reduction in noise that allows you to feel settled in your home and gives you those feelings of privacy and well-being, and not think of moving every time the neighbours make noise next door. And you just simply don't get that by installing something to the separating party wall alone. Now, I moved into a 3-bed semi-detached house. I moved next door to a very busy family that had 3 barking dogs and 3 teenage daughters, and they loved their music. I renovated my lounge 3 times. I took it back to brickwork 3 times over the course of 6 years before I achieved that soundproofing of a detached house. I then went on to help out thousands of other people in the UK achieve that same result I did, allowing them to feel settled in their home, comfortable in their home, feeling like they don't ever want to move. After publishing my methodologies in books, YouTube videos, online step-by-step installation courses, I'm now able to teach builders, DIYers and homeowners, not just here in the UK, but around the world too, on how to use the 4-step soundproofing method to get significant reductions in noise in their own home. My installation teams document all of our soundproofing installations as part of our open and honest approach. And I thought, if we're going to be doing the soundproofing installations anyway, I might as well share it with you guys. And that's exactly what I've been doing. I've since become recognised as one of the most honest and transparent soundproofing providers in the industry. And this has led to my companies winning multiple awards and working with some of the biggest names in the UK and abroad. And in this video, I want to combine it all and compress it down so you walk away feeling like you've got more value from this one video than you have done searching the internet for months and months, and for some of you even years. So why am I giving a completely comprehensive course away for free? Well, here's the truth. Over the years, there's been a lot of unethical selling of soundproofing products and soundproofing materials, claiming all sorts of clever decibel reduction figures. And that's because it's an unregulated market. Very few people can explain the logarithmic pattern of decibels and how that relates to reducing noise from neighbours by installing some fancy clip or channel system to that separating party wall. The truth is, decibels are irrelevant when it comes to reducing the noise from neighbours. You're either still hearing the noise or you're not. It's either irritating you or it's not. Yeah, sure, that decibel meter allows you to show the difference before and after on a screen. It also allows you to get that bit of paper that shows that your new development meets that current building standard. But with a lot of new build properties these days, you can still hear your neighbours. And I'm sorry, I only hear about the bad ones. But my point is, you don't have to learn about decibels and what they mean in order to soundproof your home against noise from neighbours. So in this video, we are not going to be covering decibels. As I said, I've soundproofed thousands of homes so homeowners can stay in the home they love, and understanding the logarithmic pattern of decibels has not played any part in that. You're either still hearing the noise after that soundproofing installation or you're not. And if you are, then you need to soundproof more noise paths, which we're going to later on in the video. So my goal here is to get that message out to as many people as possible. And hopefully, after you've watched this entire course tutorial, you're going to get so much value that you're going to feel compelled to share it with everyone you know and help me achieve my goals. Sound fair? Alright, if that sounds fair, we're going to get stuck straight in. But before we do, make sure you bookmark this video and get a method of taking notes. Commit to this program. Don't treat this like another YouTube video. This is going to be your textbook for learning how to professionally soundproof your home. And for a lot of you, you're going to be finding out whether you are soundproofing or moving. Some of you might have already tried soundproofing, and some of you might just be thinking of soundproofing. Some of you might be a builder or DIYer in the trade and you're thinking of adding soundproofing as another added string to your bow. What I would say is maybe put some time aside in the diary to return back to some of the key parts of this video. Maybe some of the practical bits of the course tutorial when you're actually doing the soundproofing installation, when you're putting materials on the wall. All right, let's get stuck in. I hope you got a method for taking notes. We're going to get stuck into all that technical stuff and how to put materials on the wall and all of that cool stuff. And hopefully I'm going to do that in a way which doesn't overwhelm you or confuse you. But before we do, I want to give you some expectations, because for some of you, before you clicked on this video, you might have had some questions going around in your head, like, will the soundproofing work? Will it actually stop the noise? Or how much is it going to cost? And can I do it myself? And for some of you, there might be other questions like, how much space is this soundproofing going to take up? And can I actually do it myself? I mean, how much building knowledge and experience am I going to need to soundproof the room myself? So I want to cover some of that stuff off now, and that's really important because I want to show you a way in which you can understand what successful soundproofing means to you, and that's going to help you understand how long it's going to take and how much money you're going to need, and that's going to be really motivating for you. You see, when you understand the truth about this stuff and you know the answers to those questions up front, that's going to give you the ability to put them to the side, and that's going to give you the motivation and the ability to focus on the actual learning of this video. And if you're time and money pressured and you're thinking you can fast forward this video and maybe stick some cheap panel system or some clip or channel system to the alcoves either side of the chimney stack, then ultimately that's going to affect your mindset and your ability to learn this stuff. And ultimately, you're not going to get a good reduction in noise. You're going to have to want to do this in order to get a good reduction in noise. And you're going to have to take the time and that attention to detail to get that significant reduction in noise. So what does successful soundproofing look like for you? I want you to think about your current noise issue and then write them down. Think about those things that are bothering you the most, those noises that are coming through from the neighbours. And that might be music playing, dogs barking, doors banging, things like that. And then I want you to write down what you would like to do if your home was soundproof. So if I write down here, noises to stop. And now I'm going to write down those noises that I don't want to hear. What I would like to do if my home was soundproof. For example, I want to come home and not hear the neighbours' TV playing. I wanted to not hear their conversation. And that might be muffled conversation for some of you. For me, I could clearly make out words of what the neighbours were saying. Another thing was I wanted to be able to relax in my lounge and not hear the neighbours. Another one would be a good night's sleep. Yeah, so for you, you might have a long list. Right list is, just keep going. And the next thing I want you to do is then give each one of them a score. So out of 10, 10 being the one you really want to solve, the one you really want to make happen. So for me, I really didn't want to hear that groan of the TV. I want to be able to not hear that TV in my lounge, basically. So that's a 10. Conversation, yeah, that was about an 8. Didn't hear the conversation all the time. Relax in my lounge, yeah, I wanted to relax in the lounge and not hear that TV. Good night's sleep, well, they went to bed at the same time we did, so that was a 5 for me. And next, I want you to think about what rooms you're hearing those noises. So for me, it was the lounge. Oh, the lounge. That I also heard them in the bedroom. And the hallway, and the kitchen. And for you, you might have a longer list as well. And now I want you to give those a score. So which one of those is most important to you, where you want to stop the noise? So for me, it was the lounge. Bedroom, again, was about a 5 because they weren't playing music all the time when we were going to bed. We tend to go to bed at the same time. And the hallway, yeah, 2, we heard them coming and going and hear the doors bang, and I didn't relax and hang out in the hallway, so it didn't really bother me. And that was the same for the kitchen. I give that a 2 as well, because I was always doing stuff in the kitchen. I was always making noise myself. So again, the noise didn't bother me much in the kitchen. So just from doing this, and again, you will have a much bigger list than I have, you can see, what does successful soundproofing look like? Well, I'd like to soundproof my lounge against TV noise and a bit of conversation for a bit of privacy, so then I can come home, relax in my lounge and not hear the neighbour's TV anymore. And that's what successful soundproofing would look like, certainly as a phase 1 for me. So I now know I can focus on that one room. I can soundproof that lounge really well, soundproofing all of the noise paths in that lounge. You see, you don't have to soundproof your whole house. Once you've done one room really well, that room to retreat to, that room that you don't hear your neighbours anymore, you're empowered. You're empowered because you know what it takes to soundproof your home. You're empowered to make that decision, right, instead of soundproofing that bedroom this year, I will go on holiday, yeah, because you know how long it's going to take, you know how much it's going to cost, and you know the soundproofing result. And once you know this and you know what's possible, you can then put an action plan together to soundproof the rest of the house if you choose. One of the biggest mistakes I hear about all the time is when a homeowner phones up, and it really does feel like every phone call, is when they phone up and they say, I've got 4 walls with a separating party wall. How much does it cost to soundproof my house? What they're implying is they think that if I soundproof the lounge party wall, the dining room party wall, the front bedroom and the back bedroom party wall alone, that's going to reduce the noise. But most homeowners, they still hear the noise from the neighbours. It's best to concentrate on one room really well. Treat all of the noise paths in that one room. I'll come on to that later on in the video. But soundproofing all of the walls in your home with a separating party wall alone, that is a big mistake. And I think if anybody is still telling you that these days, they're either a soundproofing material supplier or they haven't soundproofed their own home. They haven't laid in bed and heard the groan of that neighbour's TV or music playing when they're trying to get to sleep, knowing that they've got an early start the next day. So if it was as easy as soundproofing every room in your house that has a separating party wall, don't you think it'd be an easy problem to solve? And most DIYers and builders would be able to solve this problem. And 2/3 of homeowners in the UK wouldn't suffer from noise from neighbours. And you wouldn't be watching this video. All right, let's look at how much it's going to cost you. If you're still at the beginning of your soundproofing journey, then you may still be comparing soundproofing materials for just the party wall alone. So let's start there. Take this 3-bed semi-detached house and let's soundproof this lounge separating party wall here. Say, for example, that party wall was a 3-metre party wall. How much would it cost? We'd be looking at anything between £800 to maybe even £1,500 for the materials. The £1,500 being the better high quality soundproofing materials. Now, say, for example, that was a 6-metre party wall. We'd be looking at more like a £1,500 to more like a £3,600 for the more higher quality soundproofing materials to that lounge separating party wall. Now, say you followed the method outlined in this video and you decided to treat other noise paths or look at or consider other areas where noise is getting into that lounge, for example. And one of the first places you would look at potentially would be this window wall. Okay? Maybe you put your ear on the wall and you've listened and you actually hear the noise on this flanking window wall. So how much would it cost to treat that window wall? So say it was a 3-metre window wall. We'd be looking, let's just write window wall there. Okay, we'd be looking at anything between £600 to maybe even £800 for the better quality materials to sound deaden that window wall. If it was a 6-metre window wall, yeah, we'd be looking at more like a £800 to maybe even £1,500 for the better quality materials to soundproof that window wall, right? Now, for some of you, you might be looking at other areas to treat, such as the floor. You might have a suspended wooden floor void that needs to be treated as part of the sound insulation. And that floor could be anything between £400 to maybe even £600 to treat that floor. And for some of you, you might want to, you might even want to consider the ceiling. Yeah, that ceiling void, and maybe the whole of the ceiling or just maybe a section of that ceiling. So how much would that cost? So that ceiling, again, would be anything between £200 to insulate back or even tuck the materials up to maybe even £400 to treat that ceiling void. And there might also be another noise path in this room. Say, for example, that was a hollow stud wall perpendicular. You've put your ear on that wall and you can clearly hear the neighbour noise on that stud wall perpendicular. How much would that cost? You'd be looking at potentially anything between £600 to maybe even £800 to soundproof that stud wall perpendicular. So to do one room in your house, realistically, you're looking at anything between £2,500 to maybe even the higher end of £6,500 for those better quality materials if you really wanted that soundproofing of a detached house. And why is there such a big difference in the cost? Because it will depend on your noise problem, your amount of noise paths you have in that room. It will depend on your space that you have available, your budget, and your skill level too. Try and think of this soundproofing like an investment, like you're moving into a brand new room. Try and think of it like a renovation, like a new kitchen or a new bathroom. Yeah, arguably it's not going to add as much value to the property, but that's the way you got to think of this. It's not as if we're plastering out the room or you're having a complete new wallpaper or new featured wall. It's quite a substantial renovation. It's going to cost quite a lot. But if you get this soundproofing right, it's going to be transformational for you and your family. So how long is it going to take you? Let's take one room in your home and consider soundproofing that one room. First of all, we have to consider the preparation, the learning time, finding or understanding where your main causes of the noise are. And that might be putting your finger in your ear on the wall, finding those noise paths. For some of you that are thinking of treating road traffic noise using the 4-step soundproofing method, that might be quite easy for you to find the main cause and address those noise paths by putting your finger in your ear and ear on the noise paths, because you'd be looking out the window, see the cars go past, finding those noise paths by putting your ear on the wall. For those of you that have noise from neighbours, it might take a bit longer. It might take the week before they start playing music, or that constant noise where you can measure and test those different noise paths in your room. Then there's the designing of your new room. Are you going to have a media wall on that new soundproof wall? What plug sockets are you going to position on that new soundproof wall? Are you going to consider wall lights or that fire design? You can put whatever you want on your new soundproof wall, by the way. You just got to incorporate that into the design phase. And this is what I'm talking about. So how long will it take for that whole preparation? Realistically, we're talking 1 week to plan that renovation of that one room. Then we've got open up the main causes. And for me, for my team, my installation teams, they normally take 1 day to open up, find that main cause of the noise. Ordering the materials. I'm going to put 1 day here for ordering the materials, because you might not necessarily do all your research and order all the materials in one place. It's rare that the materials all come from one supplier, and you might find that only a few materials actually come from specialist soundproofing material suppliers. It depends on the quality of the soundproofing materials that you use, but you might also find that your ordering the materials might be a few hours here, a few hours there, a few hours there. Some of you might order all the materials in one go, and some of you might get the first few layers on and then order more materials. So I've allowed 1 day for ordering the materials. Then there's the actual carrying out of the soundproofing installation, the actual putting stuff on the wall and treating those areas. And I'm going to put 3 to 7 days, because that's going to depend on the amount of noise paths that you decide to treat, and the size of the room, and of course the different systems, what materials you're going to decide to put on the wall. I've put actual plaster the new finished walls and ceilings or floors, whatever you're doing. Not plaster the floor, but I'm going to put here 5 to 7 days, and that's to plaster and allow the plaster to dry out, because you can use dehumidifiers and things like that to speed up the plaster drying process. But 5 to 7 days I think is realistic, and of course it's going to depend on the size of the room. Then we've got to decorate, skirting, architrave, soft furnishings to finish the room basically with those fixtures and fittings. I'm going to put 2 to 3 days, and for some of you the larger rooms it's going to be longer. So realistically, just doing a little tally there, you can see that we're not talking something that's going to be done in a day, done over a weekend. We're talking realistically a 2 to 3 week renovation of that one room, and for some of you those larger rooms, maybe even 6 weeks before you get back into that room. Now here's another thing. I've put in here 4 weeks for you to test the room out. This is to evaluate your new soundproofing, to say, oh, do I actually need to do that RSJ or that window wall? It's going to take you 4 weeks before you stop muting the TV and listening out, oh, did I hear them? Or running upstairs to that room that you haven't yet soundproofed and then coming back down into that room that you soundproof and go, oh, what do we hear? Or maybe even opening up, checking the neighbour's car is still on the drive. All those sorts of things before you feel settled and adjust to that new level of noise. That normally takes about 4 weeks to do that. So I can tell you, after teaching hundreds of DIYers and builders how to soundproof their home, we're talking 2 to 3 weeks to soundproof a room, maybe even 6 weeks for some of you with those larger rooms to soundproof a room. And these are very rough ballpark figures, but hopefully you get an idea that it's not going to be something you do over the weekend. It's not going to be the case where you purchase all the materials and then get it all done over half term. We're talking quite a considerable renovation, and it's going to cost a couple of grand per room to soundproof your house properly. As you go through this video, you'll see the amount of noise paths that need to be treated, soundproofed in your own home. And when you see the amount of work involved, for some of you, moving might be a better option. You see, it's going to take some time. You're going to have to want to do this to get a good result. But look, even if soundproofing your whole house took an entire year, the time payoff is a blip in your life, and the money that you could be saving or investing instead of moving to that detached house is significant. I also want to touch on the point that a lot of homeowners, DIYers and builders, they overestimate what is achievable in a short space of time. I've just told you that to soundproof one of the rooms in your home properly would be 2 to 3 weeks, or for those larger rooms, maybe even 6 weeks to get a significant reduction in noise. And some DIYers and builders, because of the way that soundproofing is advertised, a lot of people telling you can just stick these clips and channels directly to the party wall. You don't even have to remove the plasterboard, and you just stick it on the wall and you can do it in a few days, maybe over the weekend. There's some of them telling you can put these panels either side of the chimney stack and you can stop that dog barking. It's absolute rubbish. But believe me, when they've stuck those panels on the wall and they realize, oh, it's just changed the way that they hear the sound, and they're still hearing everything they heard before, and it only takes that slight bit of noise to come through for them to feel unsettled in their home, feeling uncomfortable, feeling like they want to move. They either then go away thinking, oh, soundproofing doesn't work, or they maybe think, oh, there's a bit more to it than putting these clips and channels to the direct noise path. This then means that when they see my videos and they work with me, they underestimate the result they get when they do it properly. I don't want you overestimating or underestimating. I want you to commit to the process. I want you to take the time to learn to get that noise reduction that you want. And if you do, the next few months of your life will look and sound different. Sound fair? I want you to tell everybody in your family and your friends that you're going to soundproof your home properly and why it's important to you. Get them to respect your time when you're learning and when you're actually doing the actual soundproofing installation. And that way, that will manage their expectations on how long it's going to take, and also the transformation that they can expect as a result. And also, when you take on any new project, it's good to get yourself around like-minded people for moral support. So take part in the YouTube comments and maybe join our YouTube community. I'm now going to get stuck into all the technical parts, so this will be a good time to maybe pause the video, get a pen and paper, and come back when you're ready. Before we start removing that plasterboard and putting some rubber panels on the wall and installing sound insulation to those walls, we need to understand what noise is itself, and understanding the anatomy of noise and what all this language means is going to be the key to getting that successful reduction in noise. The first thing to understand is there are 2 different types of noise. There's the airborne sound of like TV, conversation, music, people talking next door, radio. That's noise transmitting through the air. And the other one is impact sound, things like doors banging, kids running around, footfall, stair noise, all those types of noises are transmitting through the structure of the building. So you might also hear me refer to them as structural borne noises. I'm sure a lot of you knew that already, but what does it mean for your noise problem and that neighbour noise getting into your home? So take a door banging, a very common noisy neighbours problem. Hearing that door bang, you're sat on the sofa, just about to get into a film on that Friday, Saturday night, and you boom, I can hear that door banging from next door. That noise is two different types of noise. First of all, you have the airborne sound of the metal latch, for example, hitting that strike plate. Yeah, they have that noise come through, that's transmitting through the air. Then you also have that wooden door hitting that wooden door frame, and that is transmitting through the structure. You see, if you use the wrong soundproofing materials or the wrong techniques, you will just change the way that you hear those two different types of sound. Take John and Lisa, for example. They were suffering from door banging noise next door. I think Lisa said she counted the door banging from next door 46 times in one day on one occasion. Now, they tried to soundproof their separating party wall. They used some clip or channel system that they saw online, and they installed it to the direct noise path just as per supplier's instructions. You know the story. It didn't work. They didn't get the result. You see, door banging noise was a combination of those two different types of noises. By putting an all singing, dancing, really thick soundproofing solution to that separating party wall alone, they managed to take out the airborne sound of that latch hitting the strike plate. But that wooden door hitting the door frame, that impact noise was transmitting through the structure. And it wasn't until they realised, let's disconnect the floor joist and sound deaden the window wall, that they actually got a really good result. They no longer heard that door banging. When it turns out next door were 46 times in one day, it turns out the neighbour's wife was actually bringing her husband a cup of tea in his home office while he was working from home. She'd actually enter and exit a door, closing it each time. So she'd enter the room, close the door, bring him a cup of tea, open the door and then close the door. Maybe they had puppies or cats or something. They didn't want to get into the room. But yeah, that was enough for John and Lisa to think of moving. What I want to talk about now is your noise problem and what it means for your house construction. Take airborne noise, things like conversation, TV, music playing, and let's just deep dive into those noises a bit more, because some of you might be hearing a very particular sound that's bothering you, a very particular sound that's irritating you, making you want to move. For some, it might be the way that the neighbour clears their throat in the morning or that you're hearing every day. For some of you, it might be a cough or a sneeze or something coming through, or a particular groan of the neighbour's voice coming through. I want you to really think about the noise, because if you're hearing things like the neighbour's TV and you're hearing the programs that they're watching, you can identify the program that they're watching, or worse, you can hear the TV presenter's voice on their TV. Or let me give you another example. This is high frequency I'm talking about. High frequency airborne sound coming through. Kids screeching, or kids being able to make out words from young kids. Or, you know, when your neighbour is on the FaceTime or they're on the video call and they're talking, they naturally raise their voice. So you might hear them on the FaceTime, on the video call. But if you can hear the actual person they're on the phone to, yeah, that is high frequency coming through. And if you can hear some of those examples coming through, that would signal that you have holes in the structure of your building. You have holes on that separating party wall. It may be in the ceiling, it may be in the floor, it may be in the loft, it may be around those bay windows. But high frequency, you see, it struggles to come through bricks and mortar. It comes through holes in the structure. For my house, I also had a lot of impact noises coming through. I could actually hear the neighbour plug their phone charger in and switch their switch on, and I heard that information sound every night when I was going to bed. And it irritated me so much that I actually installed a 175mm thick system to the separating party wall and a 50mm system to all of my flanking areas. Yeah, I don't hear that noise anymore. but understanding the difference between impact and airborne sound is key. So let's take that list that you made at the beginning of the course and just look at that list that I got you to write down, where it says the noises that's bothering you and what you would like to achieve if your home was soundproofed. And just go through that list now, maybe pause the video and just circle which ones are airborne sound and impact sound coming through. This little exercise is really important because for a lot of you, identifying this airborne and impact sound on your list is going to give you the first insight to how much renovation you're in for. If you're looking at your list now and you've got a lot of impact sound, you're looking at that and you can see all furniture moving, stair noise, kids running around, doors banging, then that will signal a lot of impact noise and a lot of renovation. You're going to have to sound deaden a lot of those flanking areas. You're going to have to treat a lot of those hollow voids and maybe even consider a disconnecting from the structure and a lot of fixed systems. And for some of you, that's going to be too much work and moving might be a better option for you. Because that impact noise is transmitting through the structure, it's coming through those floor joists, it's coming through those ceiling joists or down that window wall. That's right, that exterior window wall. The noise is transmitting down there and the other wall perpendicular. Soundproofing the separating party wall alone is not going to get you a good reduction in noise. You're going to have to install a combination of different soundproofing materials to the party wall and those flanking areas, and consider decoupling and isolation as well. And if you're in a brand new semi or terraced or apartment block, then those impact noises might be just the main noises that you hear. It might be those overpowering thuds and bangs that are coming through which are disturbing your sleep. And the reason for this is it's down to the construction of the building. There are actually building materials and building techniques which make noise worse and amplify the noises that you're hearing. And that's what we're going to look at next. So let's just look at a couple of building materials or building techniques which make noise worse in the home. And for some of you that use these building techniques or products all the time, this might be something you might be quite difficult to come to terms with, and you may have to find this out for yourself. For us, it's something that we have to deal with on a weekly basis. We find this out week in, week out when we do our installations. Okay, so the first one is a dot and dab plasterboard technique. This is a method of building or a method of plastering where you mix up some plasterboard adhesive and you dollop it to the wall and you fix a drywall or plasterboard to it. You tap it level, and this technique has revolutionized the speed in which we build homes. And because of that, any alternative to this technique will be more expensive and more labour intensive. So here we've got a dot and dab plasterboard technique. Here's the dollops of adhesive, and this is the plasterboard which has been dabbed to the wall. Now this is the cavity here. Now this is the cavity void where the sound resonates and it's amplified. The noise from the party wall is shooting down this cavity, amplifying the noise. So this dot and dab plasterboard technique used here was actually a 15mm acoustic grade plasterboard used on this extension wall. But we've discovered that it's actually 15mm soundbook board which has actually been dabbed to the wall here. The builder had dot and dabbed the 15mm acoustic grade plasterboard to the extension wall. Sue and Steve, the homeowners, could hear the neighbours talking in their new kitchen extension. And as you can see, this extension wall, it's not even attached. The neighbours don't have an extension the other side of this wall. The dot and dab creates those pockets of air and it amplifies the noise from the structure. Also, the noise is channeling down through those pockets of air, channeling down to that new extension wall from that separating party wall. Now, this case study with Sue and Steve is actually featured in the Noise Free Home book, and the builder had actually installed sound insulation to the chimney stack and to the party wall. To be honest, it looked like something off of one of my YouTube videos. We're here at a 3-bed semi-detached house, and we've uncovered a soundproofing attempt on the party wall and chimney stack here. Now, the builder's done the right thing by using these resilient bars and sound block board and sound deadening the wall, but unfortunately the whole thing has been covered in this dot and dab technique, which is again is amplified the noise, and the whole thing's just not worked. But my point is, the builder had used dot and dab technique to apply some of the soundproofing materials to that separating party wall. And that's why the noise was amplified. So even using this technique with acoustic grade material, so like the 15mm soundblock board and again the rubber, it amplified the noise from the structure. And don't worry, I'm going to show you exactly how to install some of these materials properly later on in the video. So if you have dot and dab plasterboard in any of the rooms that you're trying to soundproof, make sure you remove it first. Don't go over the top of it. Don't try and inject anything into it. Don't put expanding foam into all those hollow voids created by the dot and dab plasterboard technique, because with foam, noise transmits more easily through the foam than it does air. So you'll just amplify the noise. It might be easier to remove that dot and dab plasterboard technique than you think. So what are the alternatives to dot and dab plasterboard technique? Although this technique is terrible for road traffic noise, it's terrible for aircraft noise and terrible for hearing noise from neighbours. It has revolutionised the way in which we build homes, particularly the speed and the cost in which we build homes, renovate our extensions and do our conversions. But here are 3 alternatives which you could use as an alternative wall coating to dot and dab plasterboard technique. The first one is a sand and cement render. The second one is a thistle backing plaster or thistle hard wall. And for those of you that are in Europe or US, this is a backing plaster that you apply to a block, for example, before you apply a finishing plaster. And then number 3 would be a timber batten with a, say, 25mm rock wall and then a finishing plasterboard or drywall. So you could use a 25mm timber batten with a 25mm RW45 rock wall, followed by a plasterboard. These 3 alternatives will not amplify the noise from the neighbours or road traffic noise or aircraft noise. It won't channel the noise around your home either. So consider those 3 alternatives. I have done many videos on this and it does feel like I say it in every video. The dot and dab plasterboard does have to be removed from the separating party wall and any walls adjacent to those rooms. If you're doing a separating party wall in the downstairs and you've got it in the upstairs, I'm sorry, it will have to be removed as part of the installation. And I'm sorry for those of you that have a wardrobe in that bedroom upstairs with a back into it with dot and dab plasterboard behind. But to get a good reduction in noise, that dot and dab needs to be removed. Number 2 would be aerated blocks. It's known in the building industry that noise transmits easily through the old breeze blocks, right? And that's basically because they're just concrete with lots of air pumped into them. And there are aerated blocks now called thermalite blocks or Celcon blocks, and they have even more air pumped into them, making them even lighter and even worse for noise transfer in homes. They have revolutionized the way in which we build homes. You can build quicker with them. They're great for thermal, they're anti-damp, anti-mold, but noise transmits so easily through them and they're just terrible for noise. When you have aircraft noise or road traffic noise or noise from neighbours, the noise just transmits so easily through these blocks and around your house and new extension or new loft conversion. We find that the only way to sound deaden these blocks is to install a membrane to it, and it has to be the right membrane. For example, it's no good installing a thick, dense, mass-loaded vinyl to these blocks because that would channel the noise around your home. There's no point putting a clip and channel system directly to these blocks because that would channel the noise around the home. And there's no point building something in front of them because that would channel noise around your home. They have to be sound deadened, which I'm going to show you exactly how to do later on in the video. Another product which makes noise worse in homes, and number 3 on my list, is a rigid insulation, a polyurethane cyanide. Hopefully I said that right. This rigid insulation just channels the noise around your home, and that's because noise transmits easily through it, and a lot of them have a reflective surface allowing the sound to resonate. Take this flat roof, for example. This is a warm roof using rigid insulation. This is a semi-detached house, and this is the neighbour's property. This is the new extension off of the rear of the property. Any noise on the separating party wall or around that separating party wall here, for example, that will be the same all the way along this roof because the noise just transmits so easily through this product, this rigid insulation, which makes up the warm roof. It's used in so many homes, on so many apartment blocks, on so many new build properties, on so many flat roofs, because it's fantastic for the thermal value. I'm sorry to be the one that tells you about this. And again, it's one of those products you're just going to have to find out for yourself if you use this product all the time. But it does channel the noise, and it has to be removed as part of any soundproofing installation. It'd be an even longer video, like a really long video, if I was to go through the alternatives to rigid insulation. I'll put some alternatives in the free guide. But for those of you that have seen grand designs, you can build your house with whatever you want as long as you meet that thermal value or can prove that it meets that thermal value. So what do you need to do to stop these noises? To soundproof a room, you need to reduce that sound energy. And typically, there are about 5 ways in which you can do that. And the first one would be to sound deaden or dampen the sound. Imagine the noise from the neighbours coming through, it's hitting your walls. That noise causes the wall to vibrate, it resonates, just like a ringing drum cymbal. And how do you stop that ringing drum cymbal? You put your hand on it, you sound deaden it. And that's exactly what we're doing with this 20mm rubber. We're putting that on the wall and we're sound deadening the wall. A similar product we use is this viscoelastic membrane. Now, these are the only 2 products that we've used and heavily tested in domestic homes. We find that gets the best result for sound deadening the wall. I wouldn't use something like a dense mass-loaded vinyl, or certainly not on a lightweight block wall anyway. We find that the mass-loaded vinyl, or MLV for short, that tends to just channel the noise because it's highly reflective. It channels the noise into other areas of the property. This 20mm rubber that we use a lot is very soft, quite corky. It's easy to cut, and we find that it's not reflective at all. It actually sound deadens and absorbs the sound. Another way to reduce the noise is by adding mass. Adding mass is a key component of any soundproofing installation. However, it's got to be installed in the right location of that soundproofing system. For example, if you install mass straight away, you potentially could channel the noise into other areas of the property. We find that it's best to sound deaden the wall, create that resilient layer, and then add mass. For example, if you take this chimney stack, a lot of homeowners with chimney stacks, when they've put their finger in their ear and they've listened on that reveal of the chimney stack next time the neighbours have made noise, they find that the noise is pretty much the same on that chimney stack as it is the alcove. Even though that chimney stack already has a lot of mass, it's good old-fashioned dense bricks, which tend to be a lot denser than the rest of the bricks on the separating party wall, but they still hear the noise on that chimney stack. And so there's no point adding more mass to the chimney stack until you've sound deadened that chimney stack. So one product we use which sound deadens the wall is this 20mm rubber, but then we install this honeycomb sandboard product, this piece of German engineering full of tiny sand particles. That is a bit of mass, but also adds a resilient layer. And we glue that to a wall, and the glue is that resilient layer as well. I'll go more into this system a bit later, but we then add more mass with a 15mm acoustic grade plasterboard. You see how we've sound deadened the wall, we've created that resilient layer, and then we've added that mass. So mass is a key component, but it's got to be used in the right way. Another way to stop these noises is to decouple and isolate. If you're hearing extreme noises such as dogs barking, doors banging, footfall such as kids running around next door, maybe stair noise, or even if you're hearing that low frequency bass noise such as that music from the neighbours coming through, then decoupling and isolation is going to be a key part to your soundproofing installation. You will need to decouple and isolate as many of those walls, ceilings and floor surfaces in that room that you're trying to soundproof. The more of those that you can decouple and isolate, the more reduction in noise that you're going to achieve. Take Kim and Dave's lounge diner here. They were hearing everything from next door. I think Kim was saying she could even take part in their Christmas bingo games because you could hear the noises so clearly through the separating party wall. Some of the noises they were hearing in particular were impact noises, kids running around and doors banging, and in particular a washing machine on spin. They could hear and feel the vibration of the washing machine, not only in this lounge diner, but the other side of the house as well. So one thing we did is decouple and isolate the suspended floor joist from the separating party wall. And that allowed us to tuck the system down to the subfloor. Kim and Dave, they no longer hear the neighbours' impact noises coming through. They're no longer hearing that washing machine on vibrate, and we've massively reduced the noises of door banging from next door. Take Florian, for example. Florian was hearing a lot of noise from his neighbours, and he was hearing a lot of noise down this flanking lightweight breeze block wall. Rather than install sound insulation to both sides of this wall, we decided it was better to take that wall down. And then when we built a new wall in place, which separated the front and back bedroom, it was decoupled and isolated from the new soundproof wall. Whenever we install our floating frame to that separating party wall, we always decouple and isolate it as much as possible. We certainly do not use a 5mm foam tape. We use a 20mm anti-vibrational pad, which decouples the frame from the structure. I'll go into more detail with the floating frame in the direct noise path section later on in the video. But rather than getting excited about what to put on that separating party wall, we find that the best results come from the preparation stage. If you can decouple and isolate as much as you can during the preparation stage, for example, if you're cutting open that floor and you're removing those floorboards, when you put the floorboards back, they're decoupled and isolated from that new soundproofing. When you cut open the ceiling to tuck the system up, when you put the board back, it's decoupled and isolated from that new soundproofing. And that's the same for the flanking walls and all the fixtures and fittings. They're decoupled and isolated from that wall that you're trying to soundproof. So decoupling and isolation plays an important part when you're trying to soundproof a room, not just on the separating party wall system, but also on those flanking stud walls and other walls perpendicular as well. Another way to reduce those noises is by deflection, forcing the sound to change direction. We use a heavy-duty acoustic-grade drywall plasterboard, which is very reflective and forces that sound to change direction. There are not many videos on how to install this correctly. I've already shown you earlier on in the video how using this product incorrectly can amplify the noise in your home or force the sound to be channeled into those other areas of your property. So make sure you use this product wisely. We like to install it after a resilient layer. So we might install it to clips and channel systems or resilient bars when we install them to walls and ceilings. And we use this product to reflect the noise back into the absorbent layers of that soundproofing system. On this little system that I showed you earlier, we use it after the honeycomb sandboard product. Basically, with this honeycomb sandboard product, the fine sand particles, they vibrate, they struggle to transmit their sound energy to the next layer. The next layer is this highly reflective acoustic grade plasterboard, which reflects the noise back into all those layers, which makes it a really effective little system. Sometimes we use more dense, really highly reflective products such as cement board, and again we install them directly to the resilient bars, reflecting the noise back into all those absorbent layers of the soundproof system. A key component to reducing those noises is absorption, absorbing the sound. And we're not just talking about absorption materials that you would install to that soundproofing solution that you install to the separating party wall or to the ceiling or those flanking areas and maybe the floor. We're talking about soft furnishings that absorb the sound after you've completed your room. This is after painting and decorating. Absorption material is a key component after the soundproofing installation because you would have installed a lot of highly reflective soundproofing materials, especially if you've treated a lot of those different noise paths. Those highly reflective materials that you've installed to the wall means there's more sound energy bouncing around in the room. You've created more reverberation, more echo in the room.
Hi guys, so this is a little video on sound absorption. As you can probably tell from me talking, there's a lot of echo in this room, a lot of echo reverberation in this little studio that we're doing. We've just finished installing sound absorption to the ceiling. We've got a little bit more ceiling up to do, but already you can feel the room is more acoustically comfortable. There's a massive reduction in the echo and reverberation in this room.
So things like carpet, curtains, cushions, soft furnishings in the room is going to really help reduce that sound energy bouncing around in the room. So for example, you've installed a new laminate floor, a new hardwood finished floor. Maybe it's a kitchen and you have lots of highly reflective work surfaces in that room. Using sound absorption to reduce the sound energy in the room can be the difference between you not hearing your neighbours or not. Some homeowners have had a big open plan living. They've removed all the carpets. They've gone for solid wood floors or solid tile floors, and they've gone from hearing a muffled TV to being able to make out words. Other homeowners have gone from not hearing the neighbours at all to being able to make out a muffled conversation. So installing sound absorption can be a very key component, and that is the bit that you install after the soundproofing installation, after the painting and decorating. Just think of a brand new soundproof studio that has lots of highly reflective surfaces everywhere. Sound will find it very difficult to escape that room, which is why we have to install sound absorption to those areas where our ear is closest to, which is like the ceiling and the floor. And your room, if you've decided to treat all of those different noise paths, is going to be no different. You're going to have to consider sound absorption as part of the installation. I hope you've managed to download the free workbook. The link for the workbook is in the description down below. Just click the link where it says free workbook and just download it. You don't have to give your email address or anything like that. And if you have any questions at this point, please just put them in the comments down below and I'll look forward to reading them. If you're getting value from this tutorial, please consider clicking the like button and sharing it with anyone you know. All right, let's get stuck into the 4-step soundproofing method. After evaluating so many soundproofing projects, you start to see what works and what doesn't work. And I now have a strong belief that to get a considerable reduction in noise, you need to follow the 4-step soundproofing method, which is what I'm going to share with you right now. The first step in the 4-step soundproofing method is to address the main causes of the noise. Now, what do we mean by main cause? Main cause, we mean things like things in your property which are fundamentally letting noise in, amplifying the sound so much that doesn't matter what soundproofing you do, doesn't matter if you install a really thick soundproofing solution to every wall in your house with a separating party wall, or the thickest soundproofing system that you can afford, you still will hear the noise if you haven't addressed the main causes of the noise. So what are main causes? I'll give you some examples. Main cause could be missing bricks, holes in the structure. If you have a clear, great big hole in the wall, for example, if you have a great big hole above the ceiling void or below that floor void, it doesn't matter what soundproofing you do to that separating party wall, the noise is still going to come through that great big hole in the structure with those missing bricks. And we'll go into each one of these main causes in a second. But another main cause could be an RSJ, a rolled steel joist. These RSJs, they're often installed with a boxing in around them, which is hollow.
3-bed semi-detached house, this time in a lovely kitchen extension. Now this is an RSJ, a steel girder, which is going into the party wall. Now this hollow, uninsulated void of the RSJ allows the sound to transmit from the party wall all the way down. The sound going through this RSJ web of the steel, we call it, is actually being amplified and transmitting up to the client's bedroom.
And that hollow RSJ, that's often where you have a new kitchen extension, creating that open plan living. It could be in a new loft conversion. It could be above a chimney stack that you've had removed. It could be other areas of the property where you've created a set of doors, creating that open plan living. And sometimes they are above bay windows and within the ceiling as well. But those hollow RSJs, they transfer noise across the whole of the house. Like steel is one of the fastest ways for sound to travel. Noise travels so easily through it. So those RSJs are what we call a main cause. Another main cause would be hollow stud walls perpendicular. So that means when you have a stud wall which is perpendicular from that separating party wall, and they could be around cupboard under the stairs, they could be creating that ensuite in a main bedroom, they could be that separating wall between a front and back bedroom, or they could be creating that separating wall between that lounge and dining room, you know, when you have the double doors between. Hollow stud walls perpendicular to the separating party wall, because they're hollow, they're amplifying the sound. They're like when you put a glass to the wall and you're amplifying the noise from the neighbours. Well, that's exactly what they're doing for your noise. And there are other main causes, like a suspended floor void. For some of you, the older properties, you might have that big hollow void beneath the floor, and that will act as a drum and amplify noise. And then there are the common building techniques, which I've mentioned earlier, which tend to make noise worse. Things like a dot and dab plasterboard technique, and there are products like a rigid insulation and aerated block. They're all culprits too, which can be a main cause of the noise. And they're a main cause because, like I said, it doesn't matter what soundproofing you do, unless you address them, unless you treat them, soundproof them, the noise will still come through. So how do you know if you have any of those main causes around your home? What can you do? Well, here's another little homework for you. Maybe this weekend, have a look in your loft. Go up in the loft and check for those holes in the structure. Look at the gable wall and look at where that ridge is, where those purlins enter the separating party wall. Even some of you might have joists entering the separating party wall. Maybe pull back some of that loft insulation and check to see if you have holes in the structure. For some of you, it might be obvious and the holes are just right there on the gable wall. So here we have a hole going through to next door, just as expected, and that would explain that high frequency noise coming through. You've got noise from the neighbours coming through this hole, which I can get my arm through, definitely get my arm through there. Noise will be coming through there and then going down through this ceiling into that bedroom down below where we were. Now this loft insulation, you would think, but it doesn't offer any sound attenuation. So what we're going to do is we're going to install some rock wool back from the conflicting party wall. Before, we're going to brick that hole up, of course, brick that hole up with sand and cement. Look at that type of brickwork there. If you have an old semi-detached property and you have that particular type of brickwork on your gable wall, just note that that is quite a lightweight brick and noise will transmit so easily through that. You can't just put a stud frame with rock wool installed to it. You have to sound dampen that wall like I show you in the other videos, either with a viscoelastic membrane or a 20mm rubber, which is what we're going to use today. You need to sound dampen that brickwork wall because the noise transmits so easily through that. Now, what we have told by the homeowners in this property is the neighbours next door are considering a loft conversion. And if they have a loft conversion through the other side of this separating wall here in the loft, then the noise from that loft conversion will come through and it will transmit straight down into that bedroom down below, which is another reason why we're going to future-proof this loft here. We're going to sound dampen that wall with the 20mm rubber, and we're going to put some rock wool over it as well to reduce that noise transmitting down into that bedroom down below. So we bricked up that hole, and then got a great big hole, that hole, and then we look up here at the purlin. Wow, that go through to next door. Higher. Wow, okay, come back. So that's a great big hole through to next door. Wow. That would signal what you're in for the rest of the separating party wall. If you've got bricks missing up there, then just imagine what you might have on the rest of the separating party wall. For those of you that might be feeling a bit more ambitious this weekend, maybe consider pulling up some of the floorboards in the bedroom. Pull up those bedroom floorboards. This is if your joists are running into the separating party wall in the bedroom, by the way. Pull up those floorboards, check for holes around the joist there. For some of you, you might not have any, and some of you might have lots of little holes around there. And of course, lots of little holes make up a big hole. And for those of you that have suspended floor voids, you might want to pull up the floor there in the lounge diner or downstairs and check for holes in that suspended floor void, which is going through to next door. Now, some of you might have finished floor voids, and you might have a finished wooden floor or a solid wood finished floor, or laminate floor, something really nicely finished over your suspended floor, and therefore I'm not encouraging you to rip that open until you start getting stuck into your soundproofing installation. But just to give you an idea, if you have a suspended floor void, I and my installation teams would not take on your project if you said, no, Jim, we're not going into the suspended floor void. Going into that suspended floor void, treating those holes in the structure and addressing that big void there is so important to your soundproofing reduction in noise that you're going to get, that we just wouldn't take on your project if you didn't want to go into that suspended floor void. So yeah, check that suspended floor void for holes in the structure, and yeah, you need to treat that suspended floor void as part of your soundproofing installation. RSJs. I recognised early on in my soundproofing career that RSJs were a main cause of the noise. If you have an RSJ sat on your separating party wall, it doesn't matter what soundproofing you do to that separating party wall, the floor, the ceiling, everywhere, unless you address that RSJ sat perpendicular to the separating party wall, the noise will still come through. You need to open up that RSJ, sound deaden it, insulate it, and I'm going to show you exactly what to do right now. Now, our technique of opening up the RSJ, sound deadening it, insulating the web of the steel is slowly becoming recognised by the soundproofing industry. And every builder or developer that we show this technique to on site is amazed by the amount of reduction in noise you get from one side of the property to the other. They're using it in their loft conversions, their extensions, their renovations, just reducing that noise transfer from one side of the property to the other. So if you have an RSJ sat on that separating party wall, I recommend opening up the boxing in, sound deadening the RSJ with a viscoelastic membrane, and here we use a 10 kg per meter squared viscoelastic membrane called a Texsound. It comes self-adhesive, but even though it is self-adhesive, we still use the heavy-duty contact adhesive, which you can find in the free guide. Now, I would sound deaden the steel and then insulate the steel, but then coat that whole steel with the 20mm rubber. But when it is sat right on that separating party wall, I would then coat the rubber with the honeycomb sandboard product, and then 1 or 2 layers of 15mm acoustic grade sound block board, depending on your country's fire regulations. Now, some of you may have an RSJ which is sat perpendicular to the separating party wall. It might be on a brick pier which is perpendicular to the separating party wall. What I'm saying is the RSJ might be creating that open plan living. It might be above the doors, the double set of doors that used to be there. It might be above a bay window. Basically, it's not sat directly on the separating party wall. For this, you still want to sound deaden the RSJ, insulate the web of the steel, coat the RSJ in the 20mm rubber, but then use 1 or 2 layers of 15mm sound block board. So basically not using the honeycomb sandboard product. Now, if you have an RSJ which is running parallel to the party wall, if this is your party wall and the RSJ is running parallel, then I would recommend sound deadening it, insulating it, and then just going around the boxing in with 1 or 2 layers of the 15mm sound block board. So basically not using the rubber or not using the honeycomb sandboard product. This is some of the practical parts of the tutorial where you might want to consider bookmarking. For those of you that have the YouTube Premium, then download it and consider bookmarking it that way, because these are the bits that you want to refer to when you're doing your actual soundproofing installation. Here, the guys are showing you some sort of tips and tricks of what you can do when you're sound deadening the RSJ.
So in this video, I'm going to show you how to sound deaden and Texsound an RSJ. So note how I've measured round the entirety of the web of the steel, and then I'm going to cross-reference those marks, just using a scraper here, so I'll just mark it nicely. Pencil line doesn't always show, so just create a little indent. Make sure you're leaning on something suitable so you're not going to damage the floor. Slice through this a couple of times with your Stanley knife. It's quite easy to cut. Always try and keep the writing the right way up, just for neatness, as it looks a bit neater that way. And then what I'm going to do now is sort of dry crimp where the web of the steel sits. So I know the web of the steel is, say for instance 30mm. I mark 30mm from that edge, and I'm just going to very, very lightly score the back edge with a scraper. So we're not cutting it, we're just very lightly scoring it. And we'll do that on both parts, top and bottom, and that will help us to be able to fold the text sound. It will fold neatly, but it won't penetrate through to the other side. You can see that I'm just sort of going over that crimped edge. It's not cut through, but it's giving me a nice sealed edge. So it's helped when I bend it around the corner. It's going to adhere and follow suit how I want it to. This is self-adhesive. I recommend you make sure you dry fit it first. It's very sticky, so you want to dry fit it like I'm doing here. Make sure you're happy with how it fits before trying to apply it. So take off the protective peel on the back, revealing the sticky side. Make sure this is all peeled off. It will be very sticky. Once it's stuck, it's very difficult to remove. I always add a little bit of the contact adhesive spray just to ensure over time it doesn't come away or it doesn't lose its tackiness. So you do that on the back of the text sound and also onto the face of the RSJ in that web. We web it up about 45-degree angle. Make sure you're happy you've got enough surface coverage. It is easier with two people at this stage, so you can mould it into the bottom and then work your way up to the top. Starting at the top and working your way down, it's going to flap down and potentially stick sooner than you'd rather it would. And as you can see there, it's stuck nicely. Just feed it into that corner a little bit more using a nice scraper, and then you can just trim off any excess over the front so you're flush with the front of the web of the steel. Repeat the process both sides of the steel. Make sure it's in sound deadened all the way across. So this time we started at the top, just to show a little bit more difficult if you start on that top part of the web of the steel. It's definitely easier working from the bottom upwards. Then we want to do a similar thing to the underside of the steel. All the same process, using the self-adhesive tackiness and the contact adhesive spray. I'm just going to mould that over.
Now, a lot of the time we find holes in the structure when we're actually doing the soundproofing installation. When we've opened up those hollow voids, we've cut open the ceiling, we've cut open the floor, we've opened those bay windows. That's when we find those holes in the structure. Take this lounge, for example. If you would have just installed a solution to the floor, to the ceiling, done in a couple of days, and then plastered it, finished painted and decorated, you would have still heard everything you heard before. You would have gone away thinking, oh, that soundproofing doesn't work. Those clips and channels are useless. They don't work. Because look what you would have missed. If you cut open the ceiling, look at this great big hole that was there. That's a hole going through to next door. That is the neighbour's bedroom floorboards, and that is their lounge ceiling. How much noise do you think that hole is letting in? Okay, so if you would have just gone to the floor, to the ceiling, you would have just left that hole there thinking the soundproofing didn't work. So holes in the structure, they're often found when we carry out the actual soundproofing installation on that first day of cutting open the floor, cutting open the ceiling, opening up those hollow stud walls, opening up those bay windows. That's where we often find those huge holes going through to next door. So how would you treat those holes in the structure, those missing bricks? We're simply going to brick those holes up with sand and cement. You're adding that same mass. Don't use expanding foam or anything like that. Expanding foam might be the easy route, but that foam, when it cures, that sound will transmit more easily through that foam than it will do air. More easily than me and you talking in the garden. So use that sand and cement. If you find the little holes and hard to reach areas when you're up in the loft and you found a little gap around a joist or what have you, use acoustic sealant. And this is the acoustic sealant that we use. And I think that is available over lots of parts of Europe, Canada, and parts of the US as well. It's called Fire Pro, and the link for that is in the guide, which you can download. So just think, how old is your property? how many years have people been walking up and down on those floorboards, walking up and down on those joists, which is going to cause movement. It's going to dislodge bricks. It's going to dislodge that sand and cement around the joist, especially if your joists are running into that separating party wall. And just so you know, holes in the structure are very common in new build properties. You don't have to have a really old property to have holes in the structure. Some of the newest properties have huge holes going through to next door. Here you can see the neighbour's plasterboard. So we've removed the dot and dab plasterboard and it's exposed a hole going through to next door with just plasterboard between the two bedrooms. So they could hear clear conversation. They could have a conversation through the wall because 2 bits of plasterboard doesn't offer much sound attenuation. And when we looked at it on closer inspection, there's actually a hole here, 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 and here. So yeah, holes in the structure, they're not always on the older properties. In fact, if we are soundproofing a new build property, bricks, sand and cement is like the first thing that we put on the vans. Now, some holes in the structure on the separating party wall were put there for a reason when your house was built. Now, this is very common on the older properties and in particular on those suspended floor voids where you pull up the floor, oh, there's a huge brick missing, and those holes were put there back in the day to create airflow on the suspended floor void. Now, back in the day, they didn't have things like YouTube and smart speakers, which pump out a lot of noise. So noise wasn't such a big issue back in the day. But now, with the amount of gadgets that we've got, with plenty of noise coming from and people's change in employment patterns, noise is a bit of a concern, but so is fire. These holes create a fire hazard as well. So I would encourage you to brick these holes up, but you must make additional airflow. If you're bricking a hole up on the separating party wall, it would be nice to let your neighbours know that you're bricking those holes up and also create extra airflow. And there are a number of ways to create extra airflow. I'm not going to go through all of them now in this short course, but a good example would be to clear out the suspended floor voids and make sure it's all free from rubble, but also put extra air bricks at the front and back of the property. If you have missing bricks in your suspended floor void, then bricking them up is going to make a massive difference to the noise that you're hearing. You remember I said earlier about high frequency noise, and that can only come through holes in the structure. Well, by bricking these holes up, you've massively reduced the high frequency noise coming through. And again, use sand and cement bricks. Don't use expanding foam. If you're really stuck and you can't get to the area because it's in a real awkward place, then I would consider using a rock wall and an acoustic sealant. But yeah, don't use expanding foam. The laws and building regulations will be different from country to country. I would advise you to get expert advice if you do find a huge hole down in the suspended floor void that looks like it's been put there for airflow. For here in the UK, you don't need a party wall agreement at the time of filming, but I would let your neighbours know that you're bricking that hole up for, say, you can smell their cooking and you're bricking it up for a fire hazard as well. And yeah, you will massively reduce the sound by bricking that hole up as well. But make sure you increase the airflow by means of adding extra air bricks at the front and back of the property and clearing out that suspended floor void. Hollow stud walls perpendicular. Now, why are these a main cause? Take this stud wall here. This is separating the front and back bedroom, and this is above the room that we're trying to soundproof. So I asked the homeowner before we even started soundproofing to put her finger in her ear and put her ear on this separating stud wall, this wall perpendicular, which is separating the front and back bedroom. And she could clearly hear the neighbour's TV that was playing in their lounge, which was the other side of this wall downstairs. So the neighbours are playing their TV in their lounge diner, the other side of this separating party wall downstairs. But our homeowner could hear that TV clearly on this stud wall perpendicular, which was upstairs above the room that we're trying to soundproof, which was her wall separating the front and back bedroom. Now, just look where this hollow stud wall perpendicular is located. If we're downstairs, it's right above our head, above the ceiling. Now, if we'd have chose not to open up this hollow stud wall and not treat this hollow stud wall perpendicular, you would have done all of this soundproofing to the separating party wall, treated the suspended floor void, we disconnected the joists on this one, we sound deadened the separating soundproofed the window wall, we soundproofed the patio door wall. We'd have done all of that soundproofing. We'd have thought, oh, I can still hear the TV. I can still hear the TV from the neighbours. Why is that? It's because the sound was resonating in that stud wall perpendicular upstairs and then resonating and then coming down through the ceiling right above our head of the room that we're trying to soundproof. Take this wall here. This is a hollow stud wall perpendicular in this front lounge. Laura was asked to put her ear on the wall, and she put her ear on that stud wall, and she could hear the noise on this hollow stud wall perpendicular, and it was louder on that stud wall than it was the separating party wall. So you've got to find out whether you have a hollow stud wall perpendicular, because that can be the difference between you still hearing the noise after any soundproofing installation. So how do we soundproof these hollow stud walls perpendicular? We'll take this one in this room, in this upstairs bedroom, the wall separating this front and back bedroom above the room that we're trying to soundproof. For here, we would insulate that hollow void. That's right, we cut open the stud wall, we insulate the hollow voids, and then we go over the top with a 15mm acoustic grade plasterboard. And you can use 2 if you have the space available. Now, you always open up the hollow stud wall. You 100% got to open up the hollow stud wall. Now, if there were some 30mm panels that you could purchase that go over the top of a hollow stud wall, and that doesn't channel the noise into other rooms and doesn't channel the noise back down into the ceiling, then I'm sure me and my team would be using those panels and buying them by the pallet load. But unfortunately, the truth is, with a hollow stud wall, you have to open it up. You have to get to those hollow areas and insulate it with what we call an RW3 rock wall. And the density, again, is a 60 kg per meter cubed rock wall. Now, if you have a hollow stud wall like Laura did here, and the noise is very pronounced on that stud wall, it's actually in the room that you're trying to soundproof, then I would recommend decoupling that stud wall from the party wall, and that means run the what you installed to the direct noise path of the party wall, run that all the way through. So you're taking the upright stud of that stud wall out, running the soundproofing all the way through, and then rebuild the stud wall just isolated from the soundproof wall system you've just installed. Now, for some of you, if that's too much work to decouple that stud wall from the separating party wall, then another method you could use is resilient bars or resilient channels. You've still got to open up that stud wall and get to that hollow void, insulating it with a rock wall, but then install resilient channels and then 2 layers of 15mm soundblock board. Now, stud walls perpendicular really are a main cause of the noise, but we're going to look at stud walls later on in indirect noise paths, where the stud walls are located maybe the other side of the room wall, or maybe around stairs and cupboards and other things like that. A good rule of thumb would be to insulate any hollow void that you have in the room that you're trying to soundproof. Okay, so in this main cause section, we've looked at bricking up holes in the structure using sand and cement, not using spray foam or rigid insulation, and in those hard to reach areas, potentially using an acoustic sealant and sealing up around the joists and those smaller holes with acoustic sealant. We've then looked at RSJs, whether that's an RSJ sat on the separating party wall, an RSJ on that wall perpendicular, RSJs over bay windows, or creating that new open plan living. They need to be, again, the boxing in opened up, sound deadened, insulated, and then use what I've just showed you with the rubber, the soundboard, the 2 layers of 15mm soundblock board, depending on where your RSJ is located. And then we've just looked at hollow stud walls perpendicular, and remember, they can be located outside that room that we're trying to soundproof. So if you're trying to soundproof a bedroom and you've got a loft conversion upstairs, you're going to have some hollow stud walls perpendicular in the loft that you've renovated upstairs above that bedroom that you're trying to soundproof. The other main causes that we looked at were those building materials which channel the noise around your house, such as aerated blocks, which have to be sound deadened with that 20mm rubber, the rigid insulation, such as the Celotex Extratherm, those types of rigid insulation that have that aluminium foil on the back. Yeah, ideally remove this if you can. And then the building technique, which is dot and dab plasterboard, that absolutely has to be removed from any wall that you're trying to soundproof. Don't go over the top of it. Don't try and inject anything into it. Removing it may be quicker than you think. And what I was saying earlier, it has to be removed from those walls perpendicular as well, especially if you put your ear on the wall and you hear the noise on that dot and dab plasterboard that's on that window wall, the other wall perpendicular. Now, a good thing to do right now would be to pause the video and look for those hollow stud walls perpendicular. Check for any hollow voids, maybe check to see if you have any potential RSJs, or for some of you that are feeling a bit more ambitious, check for those holes in the structure. Use a post-it note when you find those hollow voids. Put the post-it note on the hollow void. Just check, is that hollow? Yeah, okay. So next time the neighbours are making noise, that will be an area where you put your finger in your ear on that hollow void, and then write down what you're hearing. You will then know whether you need to treat that area, and you can add that to your action plan. The direct noise path. Step number 2 in the 4-step soundproofing method. You're probably getting a bit excited now and thinking, oh, I could install some 20mm rubber to that separating party wall. Maybe some of you are thinking that viscoelastic membrane, that's a bit thinner. Maybe that might be better suited to your separating party wall. But first, before we rush into any of that, we've got to understand what is the direct noise path, because for a lot of people, it's very unclear what the direct noise path is. Take this front lounge here. This has an alcove, chimney stack, and another alcove. For a lot of material quotes that you may have already received, the meterage of soundproofing materials will just cover this yellow area, yeah, to the floor, to the ceiling, and maybe around the chimney stack. Now, what sort of reduction in noise do you think you will achieve if you installed the thickest system, maybe an 8-inch soundproofing system to that alcove, and let's go round the chimney stack in that 8-inch system as well, and to the other alcove as well? What sort of reduction in noise do you think you'll achieve? Well, the answer is probably none, okay? And the reason for that is you would have missed some of the key areas. The area above the ceiling is a key direct noise path. That area below the floor is still the direct noise path. And that area at the fire back is still the direct noise path. So this room here, a lot of people will quote you to just treat the yellow area, but they would have missed that area above the ceiling, that area below the floor, and say the fire back. That plasterboard to the ceiling doesn't offer much sound attenuation. Those floorboards which cover that void to the floor, even if you had a carpet on there as well, that doesn't offer much sound attenuation. Otherwise, we would just cover our walls with plasterboard, floorboards, and carpet, right? So the direct noise path is always that area above the ceiling, that area below the floor, and if you have a chimney stack on the wall, that fire back too. Now, for those of you that are considering soundproofing that room downstairs and you have a concrete floor, I'm not saying can go up the concrete floor. You don't need to go into the concrete. But for those of you that are doing an upstairs bedroom with wooden joist construction, then yeah, going into that floor void is key. For those of you who have a suspended floor, yeah, you need to go down into that floor void. And for those of you who have basements as well, you need to cut open the floor, go down, chucking the system down. Now, for those of you that have done a soundproofing attempt, or maybe had people come into your home and install something to a room with a separating party wall, if they've done that room in maybe a couple of days, there's no way they would have tucked the layers up above the ceiling. They wouldn't have cut open the ceiling and molded the different layers around the joist, and they wouldn't have cut open the floor and tucked those layers down beneath the floor void. They may have installed rock wool between the floor void or above the ceiling, but they wouldn't have cut open the ceiling and cut open the floor if they've done it in a couple of days. And the reason I know that is because cutting open the ceiling and tucking the system up and tucking the system down is about 80% of the work. This is the difference between your soundproofing installation take for the separating party wall taking 2 days to maybe 4 or 5 days. It's a lot of work to tuck the system up and tuck the system down. So you've got a good idea of what the direct noise path is. You know that some of you are going to have to cut open that ceiling, and for some of you are going to have to cut open the floor, and for some of you are going to have to take that stove out and treat that fire back. But what do you actually put on the direct noise path? What materials do you put on there? There's so much choice. I've read all these different things. What do I put on the direct noise path? Okay, so this will come down to the noise problem that you have, the space that you have available, your budget and your skill level. And that's probably why people can't give you an exact answer. But what we like to do is we like to sound deaden the wall first. And those of you that watch my other videos will see that we apply this 20mm rubber, which sound deadens the wall. And don't worry guys, I'm gonna show you all the magic bits, all the rest of it later on in the tutorial. I just don't want you to go rushing ahead and installing something to the direct noise path alone until you've watched the rest of this tutorial. Another product that we use to sound deaden the wall is this viscoelastic membrane, this Texsound. This 10 kg self-adhesive Texsound, which we also spray with the contact adhesives, this heavy duty non-chlorinated fire rated contact adhesive. We spray that before we apply that to the separating party wall or to an RSJ or around 4-inch waste pipes. We always use the contact adhesive as well as the self-adhesive version. So you can apply the viscoelastic membrane to the separating party wall, direct noise path. You sound deaden it first with either this or the 20mm rubber. By far, the 20mm rubber does outperform the viscoelastic membrane in terms of sound deadening, and I would recommend the rubber. It has to be the right rubber. You can see this rubber is very easy to cut, very easy to mold and work with. It's not reflective in any way, and it has absorption qualities as well. Remember, your wall is like a ringing drum cymbal, and we need to put our hand on it to sound deaden it. So we don't want to go building something in front of it and just leaving it to resonate. We'd rather put our hand on it, sound deaden it, and then build something in front of it. And our most popular system, the most popular system that we install day in, day out, is our floating frame. The floating frame is by far the most popular soundproofing solution which we install to the direct noise path. We have filmed detailed lessons on how to install each individual layer of the floating frame and how to build the floating frame itself, and that's featured in other soundproofing courses. But basically, the floating frame is decoupled and isolated from the structure. So it's decoupled from the ceiling, decoupled from the floor, decoupled from the flanking walls. So it's not built like a traditional stud frame. Noise finds it very difficult to get into that frame, and that's why we're able to get superior reductions in noise by using this method. The combination of materials which has been used in the floating frame has been perfected over the last 17 years. It was originally designed for noise from neighbour projects, but we now use it on drum rooms. For example, we build floating rooms within a room to get superior reductions in noise for our drum room studios. I'm not going to go through the floating frame in this Soundproofing for Beginners tutorial because I've got you a really good system that most DIYs and builders will be able to install with only a handful of hand tools, and I'm going to show you that in just a bit. But as you're probably gathering from watching this far into the course, what you put on that separating party wall is a very small part of the actual soundproofing installation. Your soundproofing result, your noise reduction, is ultimately going to come down to your installation method, your attention to detail, and you going that extra mile to cutting open the ceiling, cutting open the floor, and treating all of the direct noise path. If you're interested in learning more about the different materials in which you can install to the direct noise path, then get yourself a copy of the book, The Noise Free Home. The link for the book is in the description down below. But look, the next section which we go into is one of the most important sections of the tutorial. This section was going to determine how much renovation you're in for. It's going to give you an idea of cost, and for some of you, this will answer your question of whether you're soundproofing or moving. Indirect noise paths. Step number 3 in the 4-step soundproofing method. If you're only going to take in one part of this tutorial, then this is the section you really want to listen to. This is the most important part of any soundproofing project. If you've ever wondered why people go to great lengths to soundproof every wall in their home that has a separating party wall, they've done all the decorating, they put all the carpets down, everything finished, yet they still hear their neighbours or they still hear that noise coming through, then the main reason for that, or one of the key reasons why they still hear the noise, is flanking noise transmission, otherwise known as indirect noise paths, and that's exactly what we're going to look at in this section now. So what do we mean by indirect noise paths or flanking sound transmission? Take an apartment. Our apartment owner, they're hearing everything from that ceiling above. They're hearing doors banging, music playing, dogs barking. They're hearing all of that noise directly through the ceiling. But they're also hearing that noise when it reaches a certain volume or certain decibel, we should say, and it's entered the structure. They're hearing that noise down the walls as well. They're hearing flanking noise transmission down the walls, and that noise from the walls then radiates into the room and we hear it. That's called indirect noise paths. Another example would be an apartment owner and they're hearing a lot of noise through the floor directly. They're hearing music, TV, gatherings of people directly through the floor from the neighbours in the apartment down below. That noise is coming up directly through the floor. But when that noise reaches a certain volume, certain decibel, they're also hearing that noise up the walls from down below. They're hearing the noise come up the walls and then radiate from the walls into that room. That is indirect noise path. The noise is flanking up the walls. So for you as a homeowner, if you have noise from neighbours and say this is your separating party wall here, for example, and you're hearing everything through that separating party wall, when that noise reaches a certain volume from the neighbours, they're playing that loud music, that dog's barking, those doors are banging, that noise enters the structure of the building. So these are flanking walls. This bay window, for example, this separating wall between the lounge and diner, or this patio door wall. And say if you have an upstairs room, that might be the separating wall between a front and back bedroom. Now there's a lot of noise flanking down this window wall. When we asked our homeowner to put her ear on the wall, she actually put her ear here on the window wall like this, and she could clearly hear all the noise from the neighbours through the separating party wall along this window wall. So we're going to show you how to sound deaden this window wall, because if you had a sofa here and you're watching the TV, that is a wall where your ear is closest to. For some of you, you may not have a wall separating the lounge and diner. You may have an RSJ creating that open plan living, and therefore you might have just a small section of the wall here. That is a flanking area. But this archway wall, I just want to show you what we're going to do to this archway wall, because here, this is another area where the homeowner is hearing clear noise from the neighbours. She could put her finger in her ear and put her ear here on this archway wall, we call it. And the noise is so pronounced here and the other side too. So what we need to do is we need to sound dampen this wall too. A 50mm system all the way around and treating that RSJ. And this is the extent of the sound insulation that's required to reduce the noise from the neighbours. Some people with bay windows, they not only have the flanking noise transmitting through the structure, so all the way along that window wall, but they might have a hollow boxing in above the bay window as well, which is also a flanking area. Sound doesn't just transmit through those walls, it also transmits through those floor joists, through that concrete floor, through those ceiling joists as well. If you have a suspended floor with the joists running into the separating party wall, noise will transmit through those joists and then, or along those joists, and then radiate into the room from the floor. A suspended floor will have that hollow void, which will amplify that sound into the room, which is why we say that's a main cause. A ceiling, where you have a hollow ceiling, the noise will be transmitting through the joist, but also the hollow void of the ceiling, the uninsulated ceiling, will amplify that sound further, and the sound will radiate from the ceiling into the room. So you may be starting to see how important flanking sound transmission is when we're trying to reduce noise from neighbours. Here's another example of how important flanking sound transmission can be when trying to reduce noise from neighbours. Our homeowners here in this room, they suffered from doors banging, sliding wardrobe doors and dog barking. Our homeowners, they went to bed early. The neighbours, they went to bed a bit later, more like 11, 12 at night. Now, when the neighbours went to bed, every night, our homeowners would hear the sliding wardrobe doors and the coat hangers on the rail, which was a built-in wardrobes the neighbours had the other side of this separating party wall. They understood that the flanking noise was coming from the floor. The noise was transmitting through those floor joists and then radiating up through the floor and waking them up. That was the flanking noise transmission of those sliding wardrobe doors. It was an impact noise transmitting through the structure, so it's transmitting through the floor. As part of the soundproofing project, we installed a floating floor system. That's a combination of materials which is not glued or screwed to the joist. It's isolated from the walls that we've soundproofed all the way around. So when the homeowners step in off of the landing, they're stepping onto that floating floor, which again is decoupled from the walls all the way around, not glued or screwed to the joist. So therefore, the vibration from those sliding wardrobe doors and doors banging coat hangers and dog barking, it doesn't vibrate through the new floating floor and vibrate through the bed and wake them up. Another example, a more common example of flanking noise transmission, for some of you, you might hear the neighbour's TV diagonally down below in their lounge. So the neighbours have got the TV on in their lounge, you've gone to bed early, that noise is coming up at an angle diagonally up from the lounge down below. So how do you address that type of flanking sound transmission? You need to install the sound insulation in a way which treats those flanking areas. So for example, TV noise coming up at an angle, you no doubt got to open that floor and tuck the system. Whatever you install on that separating party wall, you've got to tuck it down below the floor height, maybe even sealing it up to that ceiling down below. You want to consider insulating the entire bedroom floor and maybe even a floating floor. I'm not going to be able to go through every different scenario of flanking sound transmission. You just need to note that flanking sound transmission plays a huge part in any soundproofing project. Some of the most common ones would be TV conversation noise coming up from an angle. If you have room-to-room transfer of noise, say bedroom-to-bedroom noise, then cut and open the ceiling and tucking the system up is another key way to reduce that noise coming over the system. So we're now going to look at how you can find your flanking noise paths. So how do you know if you have noise getting into your room indirectly or flanking sound transmission? One simple test that you can do next time your neighbours are making noise, put your finger in your ear and your other ear airtight against that wall.
So here's the test. Let's be clear on a few things. This is the separating party wall alcove, this is the fire back, and this is the other alcove, the other side of the chimney stack. Here we have a flanking wall. This is a wall with a dining room the other side. This is a flanking wall perpendicular from the party wall. And on the other side, we have a window wall, which is also a flanking wall. It is an exterior wall, but it's a window flanking wall. So let's talk about the test. This is the one time where you're going to want your neighbours to actually make noise. So here's the test. You want the whole of your house to be quiet, and you want to get it to a time where your neighbours are actually making noise. And you need to put your finger in one ear, so your ear airtight, so this finger's going to go in this ear, airtight so you can't hear anything. The other ear is going to go airtight against the wall. So here we are, this is the flanking wall, I'm going to put my ear against the wall, airtight without getting a neck ache. And then again on the flanking wall, on the window wall, so I'm going to go over this side here now. Finger in one ear against the wall. Listen on that flanking wall. Now you want to do that for a few minutes to listen, really listen to how much noise is coming down those flanking walls. So if you're hearing the noise down these flanking walls, you need to treat those walls. Imagine if I'm sat here on the sofa here and the neighbours are making noise and I've just treated the alcoves either side of the chimney stack. I'm still going to hear the noise here. I'm still going to hear the noise on this flanking wall behind. It's the wall where my ear is closest to. So the test is you put your finger in one ear and your other ear airtight against that flanking wall. Maybe close the curtains when you do it. We're going to test this flanking area here and the chimney stack and the other flanking wall. If you hear the noise down those flanking areas, you must treat those areas as part of your soundproofing investment.
This is your homework. You've got to test all of those walls in that room, not just the party wall. We know that you hear the noise on the party wall and you 100% need something on that party wall to barrier that sound directly. But a key area would be that window wall in the room. That's right, that exterior window wall, the area closest to the separating party wall, but also the other side of the window wall as well. And I would encourage you to maybe get a step ladder and maybe put your ear on the wall on that RSJ, for some of you that have an RSJ, on that bay window boxing in as well. Maybe leave the step ladder set up there, and next time the neighbours are making noise, just test those areas. Finger in the ear on there. What do you hear down those areas? Use the post-it notes as well. Just write down, maybe give it a scale of 1 to 10 on how bad the noise is. For some of you in the older properties, you won't have much flanking sound transmission down those areas. For some of you on the new build properties, the noise might be louder on the window wall than it is the separating party wall. And this little test may feel silly. It doesn't seem very technical. Jim, I've got an app on my phone. Surely that app will help. No, the app doesn't tell you anything. My engineers have decibel meters that cost about £12,000, and they don't go beep, 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 beep. Oh, the noise is louder on this bay window boxing in, or beep, 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 beep. Oh, it's louder on this RSJ. No, the technology just isn't there to test the different areas of your property. Now, if you hear the noise on those flanking areas, what do you treat it with? How do we soundproof those areas? There's not much space around those windows. I've got a door on that wall. I've got a radiator, windowsill. There's plug sockets. The internet comes through on that window wall. How do I treat that window wall? We're going to get into all of that later on in the course. But the first step, the most important part, is to identify your flanking sound transmission. Where is the noise getting into your room indirectly? And the only way to do that is to finger in the ear on those flanking walls next time your neighbours are making noise. And I'll do it on a number of occasions, maybe on about 3 different occasions, when the neighbours are playing music, when they've got conversation, when they've got a TV, or maybe when the dog's barking. When you've got a constant noise, don't try and catch that door banging. Don't camp out by the wall and get a neck ache just trying to catch that door banging. It's best to try and do it when the neighbours are making a constant noise, and that's the opportunity you want to test all of the areas in the room that we're trying to soundproof. But I would also go upstairs or downstairs, go to the other rooms as well, and take the opportunity to test that. You never know, you might find a hollow void that's in a room that you hear the noise clearly on that hollow void, which is outside the room that we're trying to soundproof. So what can you do if you hear the noise down those flanking areas, those flanking walls? Well, let's just take a few. Let's look at the window wall. Say, for example, you hear the noise on that area of the window wall which is closest to the separating party wall. And you've also put your ear on the other side of the window wall and you hear the noise on the neighbours on that side as well. So you're looking at sound deadening the whole of that window wall. I would recommend installing the 20mm sound deadening rubber, followed by the honeycomb soundboard product, which creates that resilient layer, and then the 15mm acoustic soundblock board. And again, we'll go into detail when we look at an installation later on in the course. But that system would offer an 80% reduction on those flanking noise transmissions down that wall. Now, if you're hearing the noise slight, say for example you hear the noise very pronounced on that window wall closest to the separating party wall, and then not so much the other side of the window, then maybe consider reducing some of the layers on the area furthest away, but still keeping that full 20mm rubber soundboard, 15mm on the area closest to the separating party wall. On that area furthest away, maybe reduce the layers, take out the honeycomb soundboard and put 2 layers of 15mm soundblock board, which still makes up that 50mm space loss. Now, for some of you with the older properties, the noise might be slight. You don't hear the noise on that window wall section, certainly not the area furthest away from the separating party wall. Maybe consider just the 20mm rubber and then 1 layer of 15mm soundblock board. Again, glued, how we're going to show you later. Now, some of you will have a bay window, you'll have an RSJ that needs to be sound deadened, you'll have a hollow void that need to be insulated with rock wool, and some of you might even have the upright studs with, you can see the felt outside. You've got a real big hollow void beneath that windowsill where the radiator was. And there you need to install a rock wool, resilient bars and 2 layers of board, 2 layers of 15mm soundblock board if the noise is very pronounced. If the noise is very slight, then maybe just insulate that void with rock wool and then 2 layers of board. Bay windows with the wrong insulation or the insulation installed incorrectly can cause condensation, so make sure you check with an expert on that before go filling that bay window with insulation. Now, for some of you, those flanking internal walls may be hollow stud walls, as we mentioned earlier, and you simply just want to insulate those stud walls and then put 1 or 2 layers of 15mm soundblock board over the top. Now, if the noise is very pronounced on those hollow stud walls, maybe consider resilient bars and 2 layers of 15mm soundblock board. When using resilient bars or resilient channels, always try to use 2 layers of acoustic grade plasterboard or sheetrock or drywall, whatever you're using. Always use 2 layers. And the reason for that is the resilient channels and resilient bars, they create a lot of movement. The board will move. So if you try and wet plaster finish over the top, you'll cause yourself a lot of cracking. You'll get hairline cracking almost immediately. So always put 2 layers, and that will give them a lot more rigidity, if that is a word. For those hollow ceiling areas where noise can come over, I recommend cutting open the ceiling and tucking the system up. And if you have joists running into the wall, that even means cutting the different layers of material around the joist using a 4mm gap and sealed with acoustic sealant. You insulate back from the conflicting party wall between 800mm and 1200mm. That's what I recommend. If you can insulate the entire ceiling with rock wool, then that would be better, as that would be even better. Now, for those hollow floor voids for a bedroom floor, tuck the system down to the ceiling down below and insulate back from the conflicting party wall. Again, if you are able to insulate the entire bedroom floor, then that would be fantastic, and that would reduce the room-to-room transfer of noise as well. If you're trying to soundproof your lounge and you have one of those old suspended floors, for example, that big hollow void that I mentioned earlier, that is a main cause of the noise, then they need to be soundproofed in a slightly different way. You do need to tuck the system down and you need to insulate back, but you do need to clear the suspended floor out and make sure there's plenty of airflow if you are insulating and tucking the system down. When you're trying to soundproof a bedroom, another indirect noise path would be the loft. This is a key flanking area where noise can come over and down through the ceiling. I know you're probably thinking it's coming through that separating party wall, but if you're hearing clear conversation, can make out words, it's highly likely that noise is coming over as well. I recommend insulating between the ceiling joists and also insulating that gable wall as well. And here you can see that's where one of the layers of the system is being tucked up through the ceiling, so that reducing the noise coming over. And one key thing to note when you're doing any kind of insulation, especially in a loft, don't go blocking up any airflow. If you have a cold roof system like this, make sure there's plenty of airflow. Don't go blocking up those eaves. And as I said, indirect noise paths is so important. It's the difference between you hearing your neighbours or not after this soundproofing installation. To get that soundproofing of a detached house, you're just treating all of those different noise paths. And the more indirect noise paths you treat, the more reduction in noise you will get. Fixtures and fittings, step number 4 in the 4-step soundproofing method. At this point, you're probably thinking, great, I know what to install to the direct noise path of the separating party wall. I know about my main causes, I know I've got to look for them. And I know about some of those indirect noise paths to reduce that flanking sound transmission. Right, let's get stuck into putting some materials on that separating party wall. Well, stop before you go ahead and go order materials. We need to take in consideration fixtures and fittings into this design phase, into this initial planning stage. I've seen so many soundproofing projects where someone's done a really good solution to that separating party wall, and then they've cut a great big hole in the wall for the socket just so they can have flush sockets. Or they've done that soundproofing and then decided they need a new media wall or built-in wardrobes or new kitchen, new bathroom, new shower or new wooden floor. Or maybe they want some of those recessed downlighters in the ceiling and they then cut a great big hole in the ceiling. Fixtures and fittings is so important. It can be the difference between you still hearing your neighbours or not if you get these fixtures and fittings wrong. You could compromise your new soundproofing if you don't take these fixtures and fittings into consideration in this initial design phase before you get stuck into your soundproofing. Although fixtures and fittings is the last stage in the 4-step soundproofing method, you need to decide on it now at the start, at the beginning, during the initial design phase, because it will affect what you install to that direct noise path and those indirect noise paths. There are so many fixtures and fittings that need to be considered, whether that's a new media wall, new kitchen, new bathroom, new shower suite, sockets, coving, lighting unit, extending those door linings, architrave, new door, new flooring, carpet, curtains, new windowsills. There are just so many to contend with, so many to consider, and they all need to be fitted back in a way which doesn't compromise the new soundproofing. Obviously, we're not going to have a chance to go through them all now, and don't worry, we're not going to. It's already such a long video, but we need to consider some of the key ones. So I'm going to take skirting. Everybody has skirting, and that needs to be put back in a way that doesn't compromise the new soundproof wall. For example, skirting being fixed back to the direct noise path. You're going to have a resilient layer of some kind on the direct noise path, and you don't want to then fix skirting fixed to the floor and then fixed to your new soundproof, because you will make the bottom of the wall that you've tried to isolate and decouple as much as possible, make it negative by installing the skirting to the floor and to the wall. What we like to do is install the skirting with a 4mm gap underneath, so it's just raised just off the floor, so any vibration from the floor is not going to get into the new soundproof wall, any vibration from the wall is not going to get into the floor, and we're not going to compromise the bottom of the soundproofing. Coving, I wouldn't recommend installing coving, that standard coving with that hollow void behind it. That's just like any wind instrument. When you blow through it, the noise is louder at the other end. You'll channel the noise around your new soundproof wall because it's now more reflective. So I would recommend just painting and decorating, seeing how you go without coving. If you really can't live without the coving, then try the coving afterwards. But if you do, maybe consider the high quality plaster coving that doesn't have that hollow void behind it. Another common fixtures and fittings is the flooring. When you replace the floorboards after you've insulated beneath the floor between those joists, make sure the floorboards are put back but they're isolated from the new soundproofing, and leave a good gap that is covered by the skirting. You should have already done all of the air tightness at this stage. The main concern is that decoupling and isolation of the floorboards at this stage. Now, for those of you that have a chimney stack on that separating party wall, you might be considering a new fire design. Some of you might have a wood burning stove, a gas fire, or even an open fire, and you're going to have to install A1 non-combusting material around that fire design. Now, it will depend on your country's building regulations, so you want to check with an expert on that, but installing that rubber and glues and the sealants and adhesives around a stove is just not going to work. You're going to have to use a different type of material around that fire. So you can start to see how the different fixtures and fittings is going to affect what you install on your separating party wall or even on the indirect noise paths. Another fixtures and fittings would be the plumbing, and again, we're not going to be able to look at every plumbing situation, but we'll take the most common one, such as a radiator on the window wall. If you are installing a 50mm system to the window wall, that radiator would have to be removed, the system drained down, the pipes extended out, and this will depend on what pipes and system you have, of course, but most of the time the pipes are extended out from the wall, so they're repositioned depending on what you decide to put on that flanking wall. For us, when we install the 50mm system to a window wall, we would put the pipes adjusted so they stick out 50mm more than what they did before to take into consideration the soundproofing. And when the wall is all completely painted and decorated, that radiator is then refitted. And with the 50mm system, you go straight for it, installing the radiator brackets straight to the brickwork. So you're pretty much just ignoring the soundproofing, just using longer screws. The electrical is a key part of the fixtures and fittings. A lot of you will have sockets on that separating part of your wall, maybe internet, wall lights and lighting on the ceiling. Now, I've never shared exactly how we soundproof electrical sockets, how we manage to put the same materials behind the socket as what we put on the wall. And I'm really excited to be sharing that with you later on in the video. But just note, you're potentially getting a brand new room. For a lot of you, you're renovating the whole room. The whole room could be plastered. So take this time to design your new room. Take the fixtures and fittings seriously, write them down in your action plan and get that room that you've always dreamed of. It wouldn't take much for your electrician to move that socket to a new location. A lot of the wall systems are at least 50mm thick. They're going over the top of those electrical wires. We did a soundproofing installation for Steve and Ruth the other day. We soundproofed their front lounge. When speaking to them about their fixtures and fittings, Ruth said, I don't want to bend down for my sockets anymore. Why do I have to reach behind that cabinet to switch that light on? Could you put them a bit higher? So yeah, we just put the sockets a bit higher. So take that opportunity to design your new room. If you want wall lights, reading lights, you can put whatever you want on your new soundproof wall. You just got to put them back in a way which doesn't compromise the new soundproofing. Okay, so far there's a lot of information there. We've talked about expectations, we've learned about the different ways in which you could reduce the noise, and I've outlined some aspects of the 4-step soundproofing method, and I've given you some homework too, which is going to be the key to your successful soundproofing installation, and the difference between you hearing the noise and not hearing the noise after your soundproofing installation. So hopefully you've been following along with the workbook and writing notes as you go. What I would like you to do now is download the Noise-Free Home Plan template. This is the exact template that I use for my builder students and DIY students that are on the Noise-Free DIY soundproofing course, and I've given it to you for free. Just click the link in the description and download your copy now. Use this to make a plan for the room that you're going to tackle first. What noises are you hearing in that room? What is the construction of that room? Write down the main causes of that room. What are the direct noise paths, the indirect noise paths, the fixtures and fittings? How do you want that room to look? Are you going to put a TV on the wall? Have you considered a media wall? Are you going to have to replace that windowsill? What about that carpet? Does that need replacing? Or how many sockets are you going to have on the wall? Try and think about your brand new room. What will it look like after soundproofing? Once you've downloaded it, print it out and keep it in that room that we're going to try and soundproof first. That way, when you're doing all the testing, putting your ear on the wall, checking out all those flanking areas for noise from the neighbours, you'll be able to add it to your action plan there and then. And also, if you see a new light or piece of skirting or carpet, or you think, oh, that looked nice in my new room, you can add it to your action plan then. Right, so here's one I made earlier, as they say. You can see I wrote the goal here was to come home, relax in the lounge and not hear the neighbour's TV anymore. What I would like to do is go through the main causes, direct noise path, indirect noise path and the fixtures and fittings for this lounge and some other case studies as well to help you out. Then I'm going to go through it again, showing you what we're going to put on the main cause, the direct noise paths, the indirect noise paths and the fixtures and fittings as well. All right, and then I would like you to do it for your own property or maybe follow along as I do it. All right, let's get stuck in. I'll put this on the screen. This is my lounge, but I'm going to use other case studies, other soundproofing installation footage, because I think that will help out more people. First of all, we need to address the main causes of the noise. Step number 1 in the 4-step soundproofing method. For me, it was dot and dab plasterboard. I was tapping the walls and I could hear those hollow sections and those solid sections just like this. Hello, this is just a little video on what is dot and dab plasterboard and how to find dot and dab plasterboard in your own home. This is a dot and dab plasterboard wall, and how can you tell it's dot and dab plasterboard? So here I'm tapping, that's a hollow sound. Okay, as I move along, it's solid. That's a solid sound. So with a dot and dab plasterboard wall, we have sections which are hollow, sections which are solid. So here, solid, hollow, solid, hollow. And that will give you an idea that it's a dot and dab plasterboard wall. Where the solid sections are, that's the dollops of adhesive. Where the hollows are, that's the hollow void behind the plasterboard where the sound resonates. So I identified that I had dot and dab plasterboard that needed to be removed. That was a main cause of the noise. Another main cause was holes in the structure. I could hear the TV presenter's voice on the neighbour's TV. I was hearing that high frequency come through and I could make out words from the neighbours. So therefore I had an inkling I potentially could have holes in the structure. So one weekend I pulled up the floorboards and I checked for those holes. My joist went into the separating party wall and I could clearly see there was holes around where the joists were going into the separating party wall. And has revealed a hole all the way through to next door. And I'm touching their floorboard, touching their floor there. Later on in the actual soundproofing installation, when I pulled up more floorboards, there was a lot more holes and clear great big holes going through to next door. For some of you pulling up floorboards, you might find that this is true for you as well. You might not see those holes straight away just by pulling up floorboards or cutting open the ceilings. You might find that later on in the soundproofing installation. Another main cause for me was that hollow suspended floor void. I checked outside, I had vents outside the property which signalled a suspended floor void. My lounge felt like a bit of a drum. It has that wooden joist construction, so yes, I had a suspended floor void. So my main cause was dot and dab plasterboard. I had holes in the structure and I had that suspended floor void because it's the age of the property. Next, I looked at the direct noise paths. For me, I had this alcove on the left, so I had to consider what to put on that alcove and then also the area beneath the floorboards, that area beneath the floorboards of this alcove. Next, I also had the other alcove, that right-hand alcove, that area beneath the floor of that right-hand alcove, and also that area above the ceiling on that right-hand alcove. I also had the chimney stack and the fire back as my direct noise path. Now moving on to step number 3, the indirect noise paths. I could clearly hear the noise down this window wall. So I put my finger in the ear, checked, I could hear the noise very clearly on this window wall, the area close to the party wall, but I also checked the other side of the window, the area furthest away from the separating party wall. I put my ear there and I could clearly hear the noise of the neighbour's TV down that wall as well. So yeah, that was a clear indirect noise path, flanking wall for me. I also could hear the noise on that other flanking wall. This is the wall opposite the window wall. For me, it was separating the dining room and the lounge. For some of you, you may not have that wall in place. You might have like an RSJ or a little section of the walls still, or you might have like double doors or something like that. Or it depends what room you're doing. But for me, this was a clear flanking area. I could hear the noise of the TV very pronounced close to the separating party wall, but it was very slight the further away I got. So right towards the corner, the area furthest away from the separating party wall is very slight. But I knew that my sofa was going there. That was my ear closest to. I was potentially going to be doing that wall. Another indirect noise path was the ceiling. Remember, I wanted my own privacy. I wanted to reflect my noise back into the room. I didn't want them hearing my conversation. So installing that mast to the underside of the joist was quite important to me. So yeah, the ceiling and the bay window. The bay window, it's 1950s house. It has a lot of drafts in there. I knew that bay window didn't have any insulation. It was a hollow void. So I put the bay window as an indirect noise path as well. And you know what? I put my ear on the bay window and yeah, I could clearly hear the TV very pronounced on that bay window. Probably more on that bay window, that hollow ceiling void of the bay window, more than the window wall actually. So yeah, that was going on my indirect noise paths. Next, it's step number 4, the fixtures and fittings. For me, I know from soundproofing many properties, soundproofing offers a lot of thermal insulation. I know that if I was to put a wood burner in this size room, it would just heat up the room very quickly. There was no need to have a fire design, certainly not one that gives out any heat. So we were going for a small sort of cubby hole section, something to put a vase in or something like that. For the electrical, I wanted a few double sockets behind the TV, and I also wanted a new double socket with USB chargers at the end of the sofa for charging phone and devices. Refitting the L-shaped sofa was really important to me, noting that where I was going to be sitting, where that sofa is, that sofa was going up against that flanking wall. Indirect noise path coming down that wall and then radiating out into the room right next to my ear. That wall was where my ear was closest to, so I knew I wanted a really good system on that flanking wall. Also, we considered the shelving to the alcoves. We wanted a new windowsill because it's the original windowsill for the bay window when the house was built, and new blinds and probably a new carpet as well. Okay, so now I'm going to go back through my noise-free plan and write down exactly what I'm going to do for each one of these sections. And that's going to give me a detailed plan for me to follow when it comes to doing my actual soundproofing installation. So first of all, the dot and dab plasterboard. We're going to remove all of the dot and dab plasterboard and clean the walls. So we know the walls are going back to brickwork where that dot and dab plasterboard is. The holes around the joists, I'm going to brick those holes up with sand and cement. I'm not going to use expanding foam, not even the expanding foam that says soundproofing on it. I'm just going to use sand and cement, and I'm probably going to use acoustic sealing around those areas which are more difficult to get to. For the suspended floor void, I'm going to tuck the system that I installed to the direct noise path all the way down. So I'm going to put a membrane down on the subfloor, which will allow me to insulate between the joists. As I said, I want to insulate the suspended floor joist because the room's a bit drafty. I'm also going to clear out the suspended floor void and check the vents are clear out the front, so I've got plenty of airflow on my suspended floor void. For the direct noise pass, I'm going to sound deaden it all with the 20mm rubber, tucking it up and tucking it down. So that'll be a 20mm rubber sound deadening to the alcoves, the chimney stack, the fire back, the reveals and the other alcove, tucking it up and tucking it down. But I'm also then going to install a floating frame to the left alcove, the fire back and the right hand alcove. For me and my house, there was also noises of dog barking. I had their cheesy dance music playing all the time, and I could hear some clonks and clangs coming through as well. So I know I needed something a bit more than the 50mm system, and the floating frame was perfect for that. The indirect noise path, starting off with the window wall, I know I'm going to install the 50mm system. So that's the 20mm rubber, the honeycomb sandboard product, followed by 15mm sound block board. I was going to put that over the whole of that window wall. At the moment, it is all dot and dab, so I know it's all going to go back to brickwork, and it was easier for me just to do that whole wall in the 50mm system. Also, I was hearing the noise both sides of the window wall, so I know I had to do the whole of that wall. The other flanking wall, the area opposite the window wall, the area where my L-shaped sofa is going to be, I was going to coat that whole wall in a 50mm system again, but because the noise was slight furthest away from the separating party wall, I know I didn't need that sandboard all the way along that wall, so I decided to go for 2 layers of 15mm sound block board fixed to the 20mm rubber. Still using the glue and the 2 different types of adhesive, but I was just saving some costs by not installing the sandboard to the entire wall. For the ceiling, I decided to go for 2 layers of 15mm sound block board installed to the underside of the joist in that lounge. Remember, I was concerned with my privacy. I didn't want them to hear my conversations, but I also wanted to be able to play music and watch movies and not worry about my noise going next door. So installing that 15mm sound block board to the ceiling reflected my noise back into the room. Remember to insulate any hollow ceiling voids, but also to patch up where you've cut open the ceiling. Remember, you've removed the mass from that ceiling, so it's good to replace that mass before boarding over the whole ceiling with, say, a 15mm sound block board, which can offer you your privacy by reflecting your noise back into the room. For the bay window ceiling, where I actually put my finger in my ear and put my ear against that bay window ceiling, that hollow void, and I could hear the neighbour's TV on that hollow void. After I pulled the plasterboard, it was actually quite small joists. I didn't really have much space to insulate there, so I actually got a roofer in to check I wasn't causing a condensation issue by insulating that void. All I would say is don't use rigid insulation and don't try and mass fill the void with a rock wall, and get expert advice if you have very small rafters on your bay window roof, for example. Everybody's bay window is going to be different. Some bay windows continue all the way up, and you might just have the when you expose the joist, it might be the floorboards from the room above, for example. So make sure you get advice if you're unsure when it comes to bay windows. But for me, I insulated that void with rock wool and I installed 2 layers of 15mm soundblock board. When it comes to the fixtures and fittings, my fixtures and fittings were quite straightforward compared to some. I wasn't having a fire design, so I just made sure that little cubbyhole had plenty of insulation and plenty of insulation to the cheeks of that opening as well. I didn't have a radiator on that window wall. My radiator was set back, but for those of you that do have a radiator, if you're installing the 50mm system, just go straight through into the brickwork behind. For those of you who have a hollow void there, if you're doing a bedroom, if you have a bay window upstairs, for example, just install resilient bars where your radiator brackets are going to go. So your new radiator brackets will be fitted to those resilient bars. For the electrical, I needed to consider the different soundproofing solutions I had on each of the walls. So I had a different combination of soundproofing materials or layers for each of the walls in this room. For the window wall, I had to consider the honeycomb sandboard product. For the alcoves, I had a floating frame. And on that flanking wall that separates the dining room and the lounge, I had a different system as well. So the electrical boxes were going to be fitted back differently. And we're going to go through how to fit the electrical and what to put behind the sockets in the next few minutes. Other fixtures and fittings I had in the room were skirting, architrave, wall lights and ceiling lights. But some of you may have other fixtures and fittings such as shelving, cabinets, TV on the wall. And so let's just take some of the common ones. A TV on the wall. If you're considering putting a TV on the wall, that vibration will be injected into the structure, even with a good soundproofing solution. I would really recommend installing a resilient layer behind your TV bracket. So when you put the bracket on the wall, before you put the bracket on the wall, consider something like a piece of heavy duty acoustic underlay. That offers a resilient layer. It's designed to reduce vibration on a floor. So by putting it behind the TV bracket, you're reducing the vibration from the TV, the sound, getting into the structure. Another fixture and fittings that might be worth considering if you're just soundproofing this one room and it might be a while before you soundproof another room, or for some of you it might not be possible to soundproof that kitchen or do that ensuite. Why not consider upgrading that door? Whilst you're doing the renovation, you could upgrade the door lining and the door. Get a more heavy duty door, but also upgrade the frame so you can install acoustic seals. That way you can shut the door to those rooms that haven't been soundproofed yet. There are so many fixtures and fittings and I'm not going to be able to cover them all now, but just one more important one while I think about it would be the acoustics within the room. Once you've done all of that soundproofing, you've created a highly reflective room. So you really want to consider the sound absorption. I recommend a carpet, or if not rugs, and if you can't do carpet and you can't do rugs, then maybe consider sound absorption. Blow up some holiday photos or get your favourite picture installed on sound absorption products. By putting this on the wall, it can massively reduce the echo reverberation in the room. And when you do this action plan for your property, don't take shortcuts. Take your time to do it properly. Open up the ceiling, cut open the floor, check for those holes in the structure. And if you find them, brick them up with sand and cement. Don't use expanding foam. Use sand and cement or acoustic sealant. And let us know how you get on in the comments down below. If there's anything you're unsure about, just put it in the comments down below and I'll look forward to reading those. Soundproofing materials. Before you go putting anything on the wall, you need to know what materials you're going to use, how much, and where to get them from. Now, once you've gone all the way through this course tutorial, this is a section that you may want to refer back to. I'm not tied to any material supplier. There is a range of places you can get soundproofing materials. Some of the more standard materials such as timber, rock wool, Soundblock 15, those types of materials can certainly be ordered from your local builders merchants. The more specialist materials like the 20mm rubber, the sandboard, the mass loaded vinyl, although can be ordered through your local builders merchants, because a lot of the acoustic soundproofing material suppliers, they have accounts with the builders merchants. I mean, I certainly used to purchase all the materials through the local builders merchants, but nowadays it is cheaper, I think, to purchase them directly from the acoustic material suppliers online and you can have them delivered as and when you need them. And I've included some of the links of the specialist material suppliers that we use in the Noise-Free Home template plan, which you can download, and the link for that download is in the description down below. But shop around. You know what you are and aren't prepared to spend on materials for DIYing. When choosing a material supplier, as well as the usual considerations of price, ease of delivery, how quickly you can get hold of the materials, there are a few other things that you might want to consider. Like the supplier's agenda. What products are they promoting? What's their philosophy on soundproofing? Are they marketing a quick and cheap approach to soundproofing, not taking into consideration those flanking sound transmissions and just trying to sell as much as they can? Are they heavily marketing their own branded products, trying to get as much margin on the sale as they can? How long have those products been around? Have they been tested in multiple homes, in real life home installations? Have they got any experience in installations themselves? And what have other customers said? What have other customers said on independent review sites like Google Reviews and Trustpilot? Don't be fooled by fancy marketing speak on dB ratings. Remember, decibels don't mean anything when it comes to soundproofing that room against noise from neighbours. You're either still hearing the noise or you're not. Now, some products might have an RW, the letters RW after them when you see the decibel rating. Look out for that figure because that shows that that product's been tested in a laboratory in laboratory conditions. But anyway, the purpose of this course tutorial is not to evaluate or promote specific materials or suppliers. If you want to see the materials that we use, check out my other YouTube videos and you'll see the materials and products that we prefer to use and we've used in thousands of real-life home installations. Okay, so let's get back to our noise-free home plan with a spreadsheet and let's go through some materials. I'm not going to go through the whole room, I'm just going to go through a few examples. I'm going to give you a few tips and pointers and leave you to then go and do your own spreadsheet. I know that you know how to calculate materials, but there might be a few things that you need to consider and a few tips might save you some time and money. So the first thing is when you measure out the room, take into consideration not just the height of that floor to ceiling, but also the floor height down to, for some of you, the subfloor. So that might be the area, if you're doing a bedroom, that might be how far you can go up into the loft down to the ceiling in the lounge down below. For some of you with a suspended floor void, that's going to be maybe for the bedroom floor boards all the way down to the subfloor. So that figure might not be 2.6, it might be 3 meters. It's going to vary on job to job. And some of you might have a concrete floor and you're measuring from the concrete floor up to the bedroom floorboards. Make sense? Cool. So then what you want to do is go through the sections that you're going to treat. So I've outlined my main causes here, got holes in the structure. So I've added a few bricks, sand and cement and some acoustic sealant. I know I'm going to have to remove that dot and dab plasterboard, so I've accounted for a skip here. Now some of you might go to the tip, so you might not have that. Suspended floor, I know I need a bit of mass loaded vinyl and rock wool. I'm potentially going to use the old floorboards to support the rock wool, so I don't need any timber there. When it comes to calculating material, take the 20mm rubber. The sheets of rubber come 1 meter by 1 meter, so you simply just want to add 10% to that. So let's just look at something like this flanking window wall here. I've taken the length of the wall by the height and then added 10% and then rounded it up. So I need 12 sheets for that. So it's based on a 4 meter wall, a height of 2.6, and then I've added 10%, rounded that figure up, it gives me 12. For the sandboard, these sheets come 1200 by 800, so you want to take the area of the wall, divide it by 0.96, and then what I like to do with the sandboard is slightly different to the rubber. It's more fiddly and harder to use, as you will see in a minute, and I allow 15%. So I would take the length of the wall by the height, times divide that by 0.96, take that figure and then I'll times that by 1.15, that allows me, gives me 15%, and of course round that figure up, it gives me 13 soundboards required. Now, when it comes to areas of your property like a chimney stack that has the reveals and the area behind the fire, or maybe a window wall when you have those window reveals and the windowsill, you may want to return the product into the window, improving the thermal value and the acoustic value of the window. It's something that we like to do, and that's going to give you a lot of cuts, and you don't want those walls and chimney stacks to look like a jigsaw puzzle with these products. So I would order plenty. Maybe give yourself a few sheets over more than you need in case you go wrong. Now, when it comes to ordering the contact spray adhesive, this is the industrial strength contact spray adhesive that we like to use. I'll put a link to this in the noise-free home template. This is industrial strength contact adhesive. It's not like your carpet adhesive or the contact adhesive that you can order everywhere. This is an industrial strength one, and it's non-chlorinated, and what you want to allow is half a can per rubber panel. So the 1 meter by 1 meter 20mm rubber, allow half a can of spray contact adhesive, and that's the same for the soundboard, half a can, and that includes spraying the wall. So you're spraying the wall, as we're going to show you in a minute, and then spray the panel. Yeah, and so you'll get 2 rubber panels to 1 can. Yeah, and 2 soundboards to 1 can. When it comes to the 8x4 sheet of the 15mm soundblock board, again, that's a different part of the system and a different layer. For an 8x4 sheet, you'll allow 1 can. And that again includes, that 1 can includes spraying the board and spraying the wall. Okay, so just another tip on resilient bars. You want to allow enough resilient bars for that second layer of whatever you decide to put on there. Now, some of you are going to install a maxi board and then 15mm soundblock board. Some of you are going to install just 2 layers of 15mm soundblock board, maybe with a mass loaded vinyl between, or maybe with a tech sound between. Now, some of you are going to use a 19mm plank board followed by a 15mm soundblock board. There's such a wide combination of different materials that you can use to those resilient bars, resilient channels. As long as you're adding mass, there are some materials that are better than others. But what I'm saying is take into consideration staggering that second layer. So that second layer, you're going to require a few more bars than you've initially laid out. If you've laid the bars out at 500 apart on a wall, for example, you're going to need a few more in there to take into consideration that second layer. And that's going to be different for everybody, because different walls are going to be different heights, different sizes, and people are going to be using different products. But just take into consideration that second layer. Have enough bars. And also, one final thing, check out the soundboard link that I've included in the noise-free home template. That's going to save you some money. Those of you that decide to use this soundboard product, you're going to want that tape, as you will see in a minute when we go through an installation. But the tape is quite expensive. Hopefully these links will save you some money. Okay, back to the spreadsheet. You can see I've outlined the different areas of my room, that lounge, that I want to treat. Here I've got the right-hand alcove, which is a different size to the left-hand alcove. And I'm going to treat the chimney stack as well, and that's going to have the 50mm system over. You've got that indirect noise path of the window wall. I can hear the noise really pronounced down there, so I want to install that 50mm system, which includes the soundboard. And then the flanking wall, I've changed my mind on that. I'll come back to that in a second. The floor, going to install some battens and insulation. The ceiling, I'm going to double board with the 15mm acoustic grade plasterboard, and so I need the 2 different types of screws. And then I've got the bay window ceiling there as well. The fixtures and fittings, I've just allowed a bit for the fixtures and fittings. I'm going to use some of the existing that's there already. Then I've got some prices here for joinery. I'm going to get someone to do the plastering for me. I'm probably going to do the decorating myself, and I'll probably have the carpet refitted by someone as well. So I've got the total cost now. I'll be able to price that, put it all in a big total. And what happened was I decided that this flanking wall, which is the wall separating the dining room and lounge for me, I heard the noise slight closest to the separating party wall. I didn't hear the noise furthest away from the separating party wall, and I decided just to keep the cost down, I changed that system. It was a dot and dab plasterboard wall, so I'm just going to replace the wall coating with a 25mm batten, a 25mm rock wool, and then a 15mm soundboard board, and that's massively reduced the cost for me. So that's one thing that you can do when you've got your spreadsheet, is go through it. If it's more than you want to spend, where can you cut costs, change the system, change the layers in the material. But just remember, by changing the layers, by reducing the amount of sound insulation layers you have in the system, you're going to reduce the effectiveness of the soundproofing. Another thing I like to do with the spreadsheet is give myself a rough idea of how long it's going to take. So with each of the sections, by laying it out like this, you can give yourself an idea of how long it's going to take. And some of you might do it in hours. For me, I like to do it in days. So I might take 1 day to do that, or 1 day to do that, another day to do that. And then of course you can outline that for the different sections that you're going to do as you do your installation, and that'll give you an idea of timescales of how long your soundproofing installation is going to take. Okay, so we now have a plan for the room. We know what materials we're going to use, and we've worked out how much it's going to cost, and we've given ourselves a rough idea of timescales as well. I'm now going to share with you exactly how to install the 50mm wall system. This is QuietCo's trademark TPS65 wall system, and they've given me permission to show this system and their installation training videos for this free course tutorial.
Hi guys, welcome to RR20 and M20 AD training video. So as you notice, it's a meter by a meter. So what we're going to do there, we're going to mark that up onto the wall that we are going to glue the M20 to. So level a line up, level a line down, and then we can start spraying our wall with the 2-part contact adhesive spray. You don't want to go too close. As you can see, that bubbles up, and then that stops the glue adhering properly. So once we've sprayed that about 8 inches away at a 45-degree angle and really webbing it up, put the isolation packers down there. It's a little bit easier to see on this piece here how the glue adheres and sort of the webbing up technique, making sure you're about 45-degree angle and 8 inches away from the RR20. If you note here, the RR20 actually curls up ever so slightly. It sometimes comes off the pallet in this vein, so when stacking it, I always stack it so the curved edges are sticking up, so the backside is always facing you when you go to work on a piece. We want to always stick this side to the wall. Once we've sprayed this, then we use the Stix light to go around the perimeter edges and just give the glue a little bit of backup. But we don't want a dot and dab technique, so notice how I'm using a very thin bead all the way across here. You note the curve, like I was explaining, so that curved edge, the corners want to go into the wall with the belly side sticking out. Have a mallet ready, is the best form. You can use a normal hammer, but tend to find a nice rubber mallet works quite well. Set it on the packers. You get one chance with this, so once you've stuck it to the wall, it's stuck. Okay, we want the isolation on the wall perpendicular as well, and then we're going to stick that. And then we can work our way across, pushing it on initially with just your hands. We want to ensure it's glued and grabbed properly, so we need to tap it with the mallet all the way round, making sure there's no air bubbles left behind and it is adhered properly. One thing I need to stress is you need to be very particular on gluing it, because once it is grabbed to the wall, it is likely that it could pull plaster off the wall, so you want to make sure you've definitely got it in the right position, and any cut pieces or anything like that, always dry fit it first. Okay, and then my best advice is be seal up as you go. It's much quicker this way, so you can seal all your joints as you are going along and working your way along. So you've got that 4mm isolation gap on the wall perpendicular and the floor also. So seal that up, and then using the scraper, scrape off any excess sealant. And then this is a close-up of how to web it up and how to use the contact adhesive spray. So you can sort of see it coming in at that 45-degree angle, and you can see it's webbing up almost like cobwebs or a spider web. I want to make sure we're nice and consistent with our coverage on this. And like I say, if we go too close with the glue, it will bubble and then it won't adhere properly. Okay, so what I'm doing here, I'm measuring the RR20 where I want it to be cut, and I'm creating a little slit in the rubber, ensuring I've got something below to protect the surface, so I'm not cutting into the floor. Create a little V shape, as you can see I've done there. You do that both edges you want to cut, So once you've got like a little slit at both ends, we'll then get the straight edge to cut through it properly. As you can see, I've got that little slit created at both ends here. Now slide the straight edge up to those two slits, so sort of lift up the two flaps so the straight edge is in the correct position you want to cut, and slice through the RR20 a series of times using a nice sharp Stanley knife blade. One final cut without the blade, and as you can see, I've got a lovely clean cut.
Okay, here I'm going to show you how to prep the wall for it. So this is how it's going directly onto blockwork. We want to brush that off, just make sure there's no dust or residue left on there, and then just knock off any high points from the sand and cement. And then again, a close-up of how this wants to go on. In the exact same way as we have previously done, we want to web it up at a 45-degree angle and about an 8-inch gap. So attach it to the wall in the exact same method, making sure that belly is sticking out so the corners are curved into the wall. Go across with the rubber mallet, make sure that adheres properly, and then we can seal as we go, and then we need to put some fixings into this. So when it comes to fixing it, we want to use a 50mm wood screw with a 7mm masonry drill bit and a brown 7mm plug. We put a washer on top of the screw, as you can see in this little cutout image, and then we drill using the stopper so we don't drill too far and go through the wall. So once we've drilled all our holes and we've got the washers ready on the screws, then we're ready to put the plugs in. So hammer the plugs in. I normally try and do a panel at a time or a few panels at a time. I find it's a bit quicker doing it that way. Hammer the raw plug into the wall until it's sitting flush with the rubber, and then hammer the screw into the raw plug. The best way to do this is sort of put your fingers behind the screw, hammer that in until the washer touches your fingers, and then we're ready to pull that in with the drill. Okay, so you can see putting the washer on the screw first. It's worth prepping quite a few of these first, and then you can see hammer that in until you've got about a finger's width there, and then we're ready to drill that into the wall. And then we want to pull that so it pulls beneath the surface of the rubber, so it's flat. If you look in the zoomed out little section, you can see it's pulled beneath the surface there. Really, we're looking for a minimum of 5 per sheet. Sometimes it may need a couple more, and you might need to put some on the outsides in the middle also. And then we need to seal those screw heads. So blob some sealant over those and then scrape it nice and flat. So seal up all the screw heads and all the joints. And then once we've done that, a full rubbered up room will look like this. So once we've rubbered up, this is what it will look like.
On an external corner, you need to make sure each corner overlaps one another so you haven't got a gap between the system. Just like you do when plasterboarding an external corner, you don't want a double edge or a set back corner. So you will see what I'm doing here is making sure the corner overlaps but finishes flush with that face wall. This is just showing you how to actually put the fixing into the RR20 itself, as you want the fixing just sat beneath the surface so it's not protruding to affect the next layer, and so you can seal it without creating a lump. As you can see, it's just beneath the surface of the RR20, and the washer and the screw together have created an anchor bolt into the wall. We seal up all edges, all cuts and all screw holes, as you can see I'm doing here. Upon completion, it should look like this. The cable is sealed, all the screw heads are sealed, all the joints are sealed, and all the edges and corners are sealed. Where possible, we always tuck the system down and around joists and up into the ceiling voids and around the joists.
Okay, so once we're fully rubbered up, this is how it should look in a room, and I'll see you guys in the next lesson. Hi guys, and welcome to the video on how to install soundboard to a direct noise path. Now, as you can see, I'm measuring the distance required here, and in this circumstance I'm going to turn the soundboard horizontally rather than having it vertically, as long as the sticker edge is facing you at all times. And then we want to offer this so it's sitting on top of those sockets with a little bit of isolation. So the first board here is actually going to sit above these two sockets, and I'll explain why in a minute. So using our contact adhesive spray, spray both parts up and make sure we about 8 inches away and roughly a 45-degree angle, and we want to web that up. Obviously you want to mark where we're going to be spraying to, so mark that onto the RR20 or the M20AD, and then work in the exact same process, carry out the same method, spray the entire area and cover it nicely so it's got to be webbed up, like I say, about 8 inches and 45-degree angle away from what we're gluing. And then using our stick slide, we want to apply a thin, even layer to the back of that soundboard. So like shown here, a nice thin even layer. Once that's been applied, get a rubber mallet ready, and then we will offer the board up and start gluing it. So we'll offer that up. Remember what this says, once it's stuck, it's stuck. So you get pretty much one shot with this. Stick it to the wall and then go round with the rubber mallet. Using the rubber mallet, hit all around the soundboard, not too hard, but enough that it squeezes any air pockets that might have formed behind the board. Okay, like I said, ensure the sticker is always facing the outside. Now for underneath for this bit, going around the sockets, we obviously want our 4mm isolation on the floor, and then measuring off our isolation packers, we can measure what we want to cut the soundboard height to. Then we mark that onto the soundboard, again making sure that face sticker is on the outside, and then using a very sharp Stanley knife and a straight edge, we'll cut through this. This will take numerous attempts to go through as it's got built-in layers, so you may need to go through a few times, and then once we've finally cut through it, the two will come apart. Now keep it on the floor like this, stand the one edge up straight away, and the first thing we want to do is tape that cut edge. As it's filled with very fine sand, we want to tape that straight away to reduce loss of sand. So leave about 50mm overhang at either corner, and then I'll show you how to apply the corners. So you want to stick it down and then pinch the corners in, making a 45-degree little wing. Once we've done that, we can fold the top edge over and apply that also, running our hands nice and smoothly along it, and again at this corner, pinch and create that 45-degree wing. Once we've applied the tape and we are happy that it's secure, then we want to sit that back onto those packers and mark around where our socket's going to go. So mark either edge of both the sockets, and then we can measure down to see how far they come, and then we can join up the lines, and that will give the cutout that is required. Square those lines down, and then again keeping it flat. It's essential to keep it flat when cutting. We use a multi-tool and we will cut those sockets out. The reason for using a multi-tool, it cuts through easily, and as I've got a small gap between the two here, it minimises the damage possible. So there'll be a small amount of sand come out as you're cutting this, that's not a concern, but you want to cut it flat at all times. Then we stand it up, and then we've got to tape this up. Now this becomes a little bit more difficult in that we need to tape the internal corners also. So as you can see, I'm taping the top corners, the 45s, and then I'm just putting a little nick on those internal corners, and then we will have to patch the corners also. So just doing the same on the single socket here, running that round and all the way up to the join. pinch those corners around, making those wings, and again just a little slit on those internal corners. Fold all that back, and then we need to address the corners on the internal side. So what we do is we put a small amount of tape round, and then we mould that round the corner, covering where we put those little slits. Do the same on the front and the back, so making sure we do the same on the front here. And remember, you want to make sure that you have the sticker on the outside. So if you've cut the sticker off, just make sure you know which is the face edge and which is the back. And then dry fit it, and then make sure we're happy with the gaps of the isolation at the bottom. It's not too tight and fits nicely around the sockets. And then we're ready to start gluing it with the 2-part contact adhesive spray. So again, about 8 inches away from the surface, about 45-degree angle, and as you can see, I'm webbing that up, just keeping the can constantly moving, because if we did keep it in a still position rather than keep it moving, it would bubble up and wouldn't adhere properly when we glue it. So once we've done that, then we also want to apply the thin, even layer of stick slide. I want to make sure we don't use this in a dot and dab form, just a nice, thin, evenly spread layer, like you can see here. So once that's applied, we're ready to fit it, making sure we're on our 4mm isolation packers, and then we can offer that up, again using our rubber mallet in a minute, knock out any of the air pockets that might be there, and tap it back to the surface of the M20AD or RR20. So tap that around there, and then we seal up as we go. So we'll seal up these joins now, seal up where it meets the walls perpendicular, and also around the sockets. I apply a small amount of stick slide just to help those glue into position and make sure there's no movement on them. Then we want to scrape off any of the excess glue, making sure we haven't created any lumps or humps here. So we'll scrape that off so it's nice and flat, and then seal along those edges with our acoustic sealant. So seal the joint and seal the edges where it meets the walls perpendicular. Again, with the scraper, scrape the excess there and ensure that you haven't left any humps and bumps, but all gaps have been sealed. Okay, and that is how to install soundboard to a direct noise path. Here's a few more examples of how it should be done, how it should look, and that is the lesson complete. So I'll catch you guys in the next lesson. In this video I'm going to show you and explain how to fit 15mm sound block to the soundboard layer. The process for this is exactly the same as how you would do it for RR20, so remember it can be applied to RR20 and soundboard. The process is still exactly the same. So I'm marking out my measurements to cut around this sort of backwards C shape, and I'm marking out the sockets and light switches. I always leave an overhang when it's onto a reveal like this, so the board actually runs past about 30mm to allow for the reveal to be fitted afterwards, and the board to be trimmed after the reveal runs into that 15mm layer. So you've got your marks, you can then look to cut this board down using a multi-tool. As you can see, I've marked this out ready, and it's going to fit into that gap there. So use your multi-tool, cut your two tops, and then I like to slice the other bit that I'm going to snap off there. And then you offer this into place as a dry fit, make sure it fits nicely. Mark out your sockets, double check those. Cut your sockets and switches out using a multi-tool.
scribe the top of the board to the ceiling if it needs scribing, and to the wall, remembering to keep that 4mm isolation gap. When we come to spray it, we want to use the contact adhesive spray, and note how I'm using a bit of a shield here so I don't get the spray adhesive onto any of the surfaces. Do this in a webbing sort of motion, so you want to create almost like a web effect on both parts, so on the back of the board and also onto the surface you're sticking, whether that be RR20 or sandboard. Be especially careful not to get adhesive on the windows and any plastics, it's very difficult to clean off. Then go around with your stick slide, applying a thin bead layer. We don't want to dollop this like a dot and dab technique, because we want to keep this nice and tight to the surface we're sticking. Offer the board into place. You get one chance with the glue. Once it's stuck, it is stuck, so make sure you've got it in the correct position before you send it back onto the wall. And once you've got that stuck, it should look like this. I'm going to show you how to do the reveals. So you measure and cut your reveals in the same way as before. Rasp up that edge so you've got a nice clean edge so the boards stick together nicely. You can see I've split this to get it in because I have got that overlap I was talking about on that first layer. So it won't fit in as one piece, but that's okay, as long as it's consistent and a nice joint. Okay, so next we have to glue the 15mm in exactly the same method as before, using the contact adhesive spray and the stick slide using a small thin bead. When using the contact adhesive spray, you want to keep it about a 45-degree angle and about 8 to 12 inches away from the surface you're gluing to. If you go too close, it will engage in together in a big ball and it will become too wet and it won't adhere properly when you go to glue it. So as you can see, I'm webbing it up, as I said before. So you can really see the web sort of effect taking place here. Spray your two surfaces that you're gluing together first, then follow on with your stick slide bead. So once you've put your nice thin bead of stick slide around, you can then glue the reveal into place. Giving it a tap as well once it's glued. I sometimes use a rubber mallet, which you'll see in a minute, to give it a gentle tap. Just be careful not to hit it too hard and damage the surface of the board. And then once that's glued and fixed, we can leave that to go off for a good few hours, and then we can trim the reveals back a bit later on. You can see I'm tapping that into place now, and as discussed in a minute, I will use the rubber mallet just to make sure it's really adhered and give it a little tap. Just being conscious that I'm only doing this very gently. Saves your hands a little bit as well. We'll leave that for a good few hours and then we will trim the reveal back later. Hope you found that useful. Thanks for watching.
Okay, I hope you're enjoying the installation clips of the TPS65W, the 50mm wall system. There's a lot of information there. Imagine what the full noise-free DIY soundproofing course would be like. The TPS65W can be installed to the direct noise path of the separating party wall and those flanking walls if you wanted to. And if you did, you could expect a 65% human perceived reduction in things like airborne noise like TV, conversation, things like that. I would still expect things like shouting, low frequency bass noise and some impact noise to still come through this thin 50mm wall system. If you wanted a bit more, you had more extreme noises from neighbours like dog barking and low frequency bass noise, then you may want to consider the thicker systems like the floating frame or the 95mm thick system, which is the 4-inch system. So this TPS65W system is a versatile little system that can be installed to all walls in that room that you're trying to soundproof. And what's really nice about this system is you can add to it at a later stage. For example, if you decided to do that window wall at a later stage in the future, then you can just add to it. You can do it at a later stage. Also, this TPS65W system is the foundation layers of our much larger systems. For those larger systems that offer the soundproofing of a detached house, then these layers of the TPS65 are what we sound deaden the wall with and the foundation layers of these larger systems. So you won't ever need to remove it from the wall. As I said earlier, I'm not going to be able to go through every fixtures and fittings in this short course tutorial, but one of the most common questions I get and one of the most common mistakes that I see is the electrical sockets, how you treat the electrical sockets. I see someone install a really good sound solution to that separating party wall and then they cut a great big hole in the wall for the socket. So I'm now going to share with you how we treat a socket, electrical socket box on that separating party wall or that indirect noise path using this TPS65W 50mm wall system. And then I'm going to go over how we treat a socket for a stud wall or a floating frame, or for those of you that want to use clip and channel systems, you can also use this technique in those wall systems too.
Hi guys, and in this video we're going to cover a couple of things. How the sockets work with M20 AD and one layer of 15mm sound block, and then also later in the video how it works with the 65W or M20 AD and 2 layers of 15mm sound block. So if it's the first option, which is M20 AD and 1 layer of sound block, we need to ensure that all the cables surface mounted on the blockwork and brickwork are either capped or cut into the brickwork and blockwork, and also capped to comply with regs here. So once the electrical has been capped, then we can cut our RR20 and M20 AD around this. What we can do around the capping, as it creates a slight bulge, we can cut a little V shape into our RR20. So it's touching at the front, but at the back we've got a little opening to create a V, and this will allow it to butt up to one another and create a nice sealable joint. As you can see on this image here, the capping at the top, you can see is down the back there, and because it's quite a difficult product to mark, we sometimes put a bit of masking tape just to cover that. And that will show you where not to fix when making the mechanical fixings. So once we've cut out with the board as well and cut around the sockets, we should look like this. So the socket near enough sitting flush with the front face of the 15mm plasterboard. So for this particular piece here, you can see I'm removing the existing box there, and then because that's been chased out into the wall, what I'm going to do is put a rubber pad onto that existing cutout, so it brings it flush with the existing face plaster. Now this is going onto a TPS65 wall, which we have the depth of 50mm, so we will surface mount the box on top of the first layer of rubber. So I glue and install this and seal this into place with a mechanical fixing, just to ensure we don't have a void behind our RR20 or M20 AD. So when installing the boxes to the front of our RR20 for a 65W or M20 AD and 2 layers of 15mm sound block, we can use a small amount of Stix light to the back of the box, and having used our grommets to bring the cables through securely, and then we can use a 25mm drywall screw like here as our fixings. So this is the process of how to do that. I want to cut a hole where the wiring is going to come through, and then once we've got that hole in the rubber, we can feed that cable through. want to dry fit this first to make sure we're happy with it. So pull that through, make sure the wiring it was within that chase behind as it was before, and then we can mark that up ready to glue it. Okay, so use the 2-part spray adhesive, spray both parts, and then apply our thin layer of stick slide to the back edge also. Allow a few seconds for that contact adhesive spray to go off, which is why I do the stick slide after, and then we can feed that into place, remembering once it's grabbed, it grabs very well initially, and if we make a mistake we could pull the plaster, so we want to get this right first time, every time. Ensure we've got our 4mm isolation at the bottom of the wall there also, and our 4mm off the wall perpendicular. So just to be clear, touching on that again, this is for a 50mm wall system where the box mounts directly, the metal box directly on top of the RR20 or M20AD rubber. We do not want to use a plastic knockout box for this, and what we don't want to do, even worse, is try and fit this after plastering. Okay, so I'm just going to go through how to cut out for a socket on a 65W. So as you can see, my first bit of board is actually sat above the socket. Now I always recommend doing this so we are only cutting out the top of a board. So I've actually fit the board on purpose this way, and then as you can see I'm marking around the socket and marking down for height, squaring that off, laying it flat, as we know this will have some sand leakage, and then cutting it with a multi-tool while it's still flat. So that is the reason we cut out the top of a board rather than the centre or in the middle or a bottom. It's a lot less sand leakage this way. So now we just need to seal those cut edges with the tape and creating the V shape in all corners. So as you can see, that's what I'm doing here. Tape the two sides first, give that a pinch to create that 45-degree V shape, and then I slit the internal corners. These are a little bit more tricky. I feed that round also, and then I apply some more for the bottom cutout section, and again dress round the corner slightly also. Okay, so once we've dry fitted this and we're happy with the fit and our isolation of 4mm, use the 2-part contact adhesive spray, spray both parts, and then apply a thin layer of our stick slide glue. I apply a little bit around the edge of the actual box on the wall as well. This will just help it stay in place and help it glue to the surface. And that is how we install around a socket with the sandboard. Never try to do it afterwards, as you'll have a whole board's worth of sand leak out from that. So this is why we do it in this way, and this is why I try and cut out the top of a sandboard every single time. Scrape off the excess sealant. So once completed, this is how a 65W wall will look with a socket incorporated into it. Here's a few more examples where we've done this around joists and tucked it also down below into the floor void also. Okay, so just to go over how to fit the 15mm on top of the sandboard, we want to cut our reveals oversized and then mark up for our sockets. Cut those out using a multi-tool. Dry fit it, make sure we're happy with how that sits, and then we can scribe it to the ceiling if necessary. Make sure we've got our 4mm isolation using a shield so our contact spray adhesive doesn't go over the edge and onto the surface of another material. Spray both parts of that up, and then we can adhere that to the wall. You do not want to try and apply a socket afterwards, as I mentioned earlier. This is how it will turn out, and you will have sand leaking everywhere. Right, so once that's complete, guys, your wall will look like this, and then don't forget to put the additional socket beads on before plastering like this. So you may need to trim the outer edge of the plasterboard slightly for this to fit correctly. You can just run around carefully with your Stanley knife. Check that's level, check that's sitting how we want to sit it, staple the corners, and then on the right hand side is an image of how it will fit once we've plastered. It will mean that plaster does not pull away from the faceplate, and also that plaster will not go inside the box. Catch you guys in the next lesson.
I'm now going to share with you how we install sound insulation behind double sockets, which is a technique that you could use on stud walls, floating frames, and for those of you that are looking at independent walls with clip and channel systems, this might be a technique that you could use for your sockets on those wall systems as well. So mark out where your socket's going to be on the material that you're going to install to those resilient bars or resilient channels, marking out where you want the socket. So next, cut open the hole for the socket using something like a multi-tool. Check the socket fits in that hole correctly. Then you're going to simply take an offcut of that material that you're going to install to the resilient bars. Now, some of you, this might be a maxi board, a 19mm plank board, or those of you that are just installing 2 layers of 15mm sound block board, then yeah, take an offcut of the acoustic sound block board. Next, you want to glue that metal knockout box, that electrical box, to that piece of material. Turn that material around, again, whether that's a maxi board, a 19mm plank board, or 15mm sound block board, and you're simply then going to glue that to the back of the board. And that way you have the same material that you've put on the wall behind the socket box. Now it will vary from system to system of how much space you have behind that knockout box. Here we've just used 1 sheet of 15mm sound block board for demonstration purposes, and that fits nicely with the resilient bars. We're going to install a sheet of mass loaded vinyl over the back of that socket. But so some of you might use a tech sound. For those of you that are using a clip and channel system to the direct noise path of the party wall, then you're going to have a lot more space. So I would recommend installing 2 layers of 15mm sound block board or maxi board or 19mm plank board to the back of the socket box. So here we've installed 1. What I'm saying is, if you have more space available, install 2 layers and then coat it with a sheet of mass loaded vinyl or a sheet of tech sound. Next, you want to feed the wire through the knockout box, and yet be sure to turn off the electrical before you do this. Make the wires safe before turning on the electrical, and then carry on with your soundproofing installation. Make sure you install the double socket where there aren't any upright studs. Be sure to seal up any gaps. Although our plasterers don't like them, we like to use the socket beads. This just avoids any chips and cracks around the socket when you come to replace the face plates in the future. Now, most people prefer flush sockets, but if you wanted to, you could just extend the wires, feed the wire through the different layers of soundproofing material through just a little hole and seal it up as you go, and go for surface mounted sockets, just like the one I've got down there. Right, okay, so over the course of this beginners program, we've been through what to expect, what you're going to need. We've looked at noise types and the 4-step soundproofing method, action plans, how to identify the main causes of the noise and other noise paths as well. We've looked at the materials that you're going to need and where to get them from. And then we've looked at an actual soundproofing installation and techniques that you can use. So hopefully now you have a better or much greater understanding of what it takes to reduce that unwanted noise in your home. So you can end up on that minority side and actually achieve that peace and quiet in your own home. So now I have a challenge for you. I'm confident I can take any DIYer off the street like you, and with the full noise-free DIY soundproofing course, get you to confidently soundproof a room in your home so you don't hear the neighbours anymore. Not only will you get to learn from professional installers, but you'll also get to learn what type of soundproofing suits you for your noise issue, for your type of property. It has detailed spreadsheet templates for calculating materials, which is already populated, so you just input your own measurements. I talked to you about all of my systems, including the floating frame. We go through all of the systems and you can follow along with the step-by-step installation videos. I talked to you about all of the fixtures and fittings, not just plug sockets, but we go through how to extend door linings, how to treat those chimney stacks and those fire designs and window reveals and window sills and coving and radiators and so much more. We go through how to treat those gable walls and RSJs in detail, and how to treat those floor voids and ceiling voids. My goal here is to get you to soundproof one room in your home really well. Are you up for it? If you've got value from this, then the noise-free DIY soundproofing course is going to blow your mind. It's an absolute no-brainer. And if you've watched this far, it's definitely for you. I think we can both agree on that. Get signed up. It's not going to be one of those crazy things where you get charged thousands of dollars or pounds. It's a tiny entrance fee, and you get to work with me and others doing the same challenge as well. You will learn more on this course than you will do anywhere else. I know, as I've seen it all before. I hope you found this valuable. Please leave any questions in the comments down below. Are you ready for the challenge? Get signed up. I'll see you on day one. Can't wait.